So I officially welcome you all for our very first class of Chemicals of Life, which is the very first topic under the first branch of biology, cell biology in senior 5, okay? Now, of course, you all know that before we introduce a topic, we always try to look at what the syllabus really wants us to understand or to capture as far as that topic is concerned. But before I take you through, of course, we have our syllabus book here. So briefly, we shall get it. It is biology syllabus. I remember I tried to show it in our very first class we had for cytology, subtopic 3. So that is senior 5 term 1, and the big branch is the cell biology. And today we are here for the very first topic or subtopic whatsoever. Yeah, you're going to look at its competence so that we have a picture of how questions shall be set, and then we shall see the content we are really going to cover. But before we do all this, this is a free class. It being a free class, that means so many people will view it across our social media platforms. So I request for a minute, for those who are on, just a minute, to talk about Science Scholars Academy as the one that has provided us with this free class. For just a minute, then we begin officially. So you all know, I told you can call me Dr. Paul, yeah, as most students call me, or they abbreviate as doctor, which is very okay. Now, I'm a tutor of science and math, of course, at Science Scholars Academy, whose vision, whose mission, and whatsoever is to create competent science scholars in Uganda. And the programs provided are strictly and strictly theory. Out of that, we don't provide. We do holiday coaching for all students in the country in line with science, biology, chemistry, physics, and math. I'm talking to those who are having our very first class in their entire life. Then we have the homeschooling program for those students without fees, for those students who have health issues that can't allow them to be in boarding school. Yeah, we hope them get the best at the comfort of their home. Then in holiday coaching, we just proceed, you get? Then these consultation, advice, and counseling, these ones are free of charge. Even at the end of this session, I'll give you some of our consultation lines. So for these other details down, you can just take a screenshot and go through later, because all of us here at least can read English. But the online video classes we have shall for only and only for now be biology, chemistry, math, and physics. The other science subjects, we just ensure that we provide the best material. By best material, I mean summarized notes, item banks, sample papers, scoring guides, and so on. So you be safe as far as your whole combination is concerned. So we are currently concentrating on students of A level. Yeah, because it is a very hard level. So we really need to see people succeeding at that level, okay? Also, the subsidiaries, ICT, GPA, and SubMath, we also handle that. So all the classes we record are always available for the whole year. Anytime you really want to access them, you access them from anywhere. Even after years, even your children will use the classes because they will be available, and we shall also be here to educate the country. Is it okay? Then our YouTube channel, Science Scholars Academy, also has our classes, okay? You just go there and watch some of them. So in case you want to get in touch, that is the contact 0753279592. You just take a screenshot and then you hand everything later. Okay, now what we are having is a biology lesson. Thank you for the time that you've given me to talk about SSA. So how do we handle biology classes? That is one. As a tutor, how do I lead it? As the student, how do you be the perfect audience for the tutor? So biology, we have so many formats. I can talk as I write. Okay, that is one format. But that one usually takes time because biology has a lot of content. So if I'm to write, I may use a lot of time than even needed. The second format is using a textbook, then we summarize the topic. Do you get? We shall use it for one of the topics. We get biological science, it's the book I prefer. There is FA, it's also very good. We read the topic together as we summarize so that you also get the technique. Hope my network is very clear. Then that is another format. That is the second. Reading a topic together in the textbook, we summarize like that, like that. Then the third option that we normally use at SSA is using our notes organized by special tutors. So what we do, we expose the notes just like this very one. Now this is the topic chemicals of life. These are our notes. So we expose them. I explain as we read. I explain as we read. But as a student, I expect you to be having a notebook somewhere where you're taking note of the things I'm speaking but not writing. That's why you're supposed to watch these videos twice before you do your name. Each video you're supposed to watch it twice. I told you about repetition as key in content retention. Okay? Now, that is about you, the student, and me, the tutor. That's how I'll be leading in any of the three ways, with the third one being the commonest. Then you as the student, you're supposed to also be taking screenshots. I also usually allow you that time at the end of the class to take screenshots for the pages having the content we have discussed for that particular class. So the very first disclaimer is that we don't sell our notes, but we simply provide some of them to our premium students who enroll for those holiday classes and the homeschooling classes. Hope that is clear. So attend this class knowing the criteria I'm going to follow as the tutor and how I expect you, the student, to be the perfect audience for this class. Hope we are together now. So very first, I'm going to introduce the topic. So, chemicals of life. Before we even read the topic, or before we even look at the contents of the topic, let's first see its competence. Its competence is going to give us a direction of how the item writers will examine us. Is it okay? So I'm going to come here and say, what do they want? They want us to analyze the properties and functions of chemical compounds. They are giving some examples of water, lipids, proteins, enzymes, and so on. So analyze the property, connect the property to the function. Remember, biology is going to be the hardest in the new curriculum. Because in the old curriculum, there wasn't anything like application. Students just used to cram and reproduce, cram and reproduce. Now, you, the new curriculum student, if you cram, well and good. If you understand, well and good. But before you reproduce, you're reproducing an application. So you reproduce from your mind and then apply on paper. Not like the old curriculum where you were simply reproducing on paper. I know that you get the difference, okay? So as we teach, understand the properties, understand the functions. Today we are covering water as the simplest inorganic chemical of life. So understand the properties of water. Relate those properties to functions and you'll be good to go. Then our next lesson shall be on lipids. I'm giving you take-home research, which will also be in that direction. What are the properties? What are the functions related to the properties? Properties are physical, physiological, structure, things like that. We are going to see it all. Just stay tuned, have your book open, listen, and don't doze. Okay? Your doctors are supposed to be sober. So that is all. So there are some things they are putting, they are saying thermal properties of water are not required. And I also hint something small about them. Yeah, there are a lot of things that were excluded in the curriculum but are so important. But as you attend these classes, I'll be guiding you. Is it okay? I'll be guiding you on what to go and read even when it is outside, especially for those who are going to go into advanced biology even after senior 6. Okay? Now, what we are really going to do today is the water part only. The next part shall be lipids and that will be yours. So we are going to see how water interacts with different substances, but of course we really need to have a very good introduction. Then we talk about water, talk about the properties, functions, and so on. Just stay tuned and be alert. Take note, take screenshots even before I give you the time. Okay? Now, very fast. We are going to first read through together. Where necessary, I first explain, then we come and read. Where not necessary, we just come and read at once. Okay? So, I gave you an introduction the other time in cytology that the branch cell biology has cytology, it has microscopy, histology, then chemicals of life. So I don't think anyone is really confused when I call this topic 1.1. Okay? Now, chemicals of life. This heading has two words. It has the chemical part and then the life part. That means these chemicals are simply there to support life. So we have started officially. So these chemicals are there to support life. All of you know life. Now we really need to know what are these chemicals. Okay? So what are they saying? They are saying that chemicals of life, or a chemical of life, is first and foremost a chemical substance. And I doubt whether anyone is hearing the word chemical substance for the first time. Chemical substance is something that has been formed by a chemical reaction. And we are going to see all this. Okay? They are saying that these ones are needed in relative or absolute amounts for efficient functioning of the organism and for healthy life. That yes, these chemicals are there to support life. By supporting life, we want the body to be functioning efficiently so that we are healthy. But they don't just do that anyhowly. The amounts needed are either absolute or relative. Someone may be like, what do you mean by those words? By absolute is they may tell you that you need this amount of proteins per day. That is absolute, cram work. You understand? You've heard of those programs on TV that a normal person should take this amount of water in a day. I think you've heard of those things. That is called absolute. Then relative, you actually relate to your current condition. They may say, for you really to have less risk of getting diabetes, let me hope people here are aware that diabetes are due to very high sugar diets. So they may say for you to have less risk of that, you should be maybe taking a certain amount of sugar. But then there are diseases that completely stop you from taking sugar. So that means they have related the amount of sugar you should take to the disease you have. That's what they mean by relative. By absolute, it is the other cram work said on TV programs. By relative, we look at the disease you have. Then we tell you what you should do in response or in reaction, in whatever, to the disease that you have. Okay? I will not waste a lot of time there. So they are telling you that chemicals of life are constituents of a balanced diet. In primary, we used to define that in science. And we say this is just nutrients made available in their right amounts and proportions. By amount, we look at how many proteins. By proportions, we mean their proportion maybe to some other nutrient, something like that. Of course, they are supposed to support life, so we expect them to be part of the balanced diet. Just like you hear of things like cytology, the study of cells, histology, the study of tissues, zoology, the study of animal behavior, and so on, you've heard of those things. So we also have a branch in biology called biochemistry. You understand? And I've told you the moment you see chemistry, we are simply talking of chemical compounds. So we are talking of reactions. And when you see bio, we mean life. Okay? Life, we mean living organisms, we mean living systems. Okay? That means you're studying the chemistry of life. You're studying the chemical reactions inside living organisms or inside living systems. Okay? So they are telling you that the study of chemical compounds found in living systems and the reactions in which they take part is the biochemistry. You're simply studying the chemistry of life, the chemistry inside living organisms. And who defines that chemistry? It's the chemical compounds inside the body and the reactions in which they take place. Someone may be like, what do you really mean? Look at glucose. All of you here know that glucose, okay, let me even not talk about glucose. All of you have ever taken something that is starch or carbohydrate like cassava. A lot of things. You've taken something that is protein like beans. So of course they are protein, that means they are compounds, chemical compounds. So when you take them into the body, they are digested in the mouth, they go to the esophagus, they go to the stomach, to the duodenum, that is the first part of the small bowel, things like that. Then after, in the end, maybe if it's carbohydrate and it is finally glucose, this glucose is supposed to be broken down in respiration to release energy. Are you getting all that? So the chemical compound is the starch, is the carbohydrate, is the protein, is the glucose. The reactions that are taking part, or the reactions in which they are participating, it's the digestion, the respiration, the breakdown, all those things. We shall be looking at them slowly as we progress. So the study of all that is what they call biochemistry. Now, you people know chemistry, and some people here do chemistry. Most of you here, BCM, PCB, BCA, BCFN. You know that chemistry has 3 branches: organic, inorganic, and physical. And you've looked at what we call organic compounds and inorganic compounds. But physical chemistry is something different. It has more of calculations. That means the main compounds in chemistry are 2: the ones that are organic and the others that are inorganic. If they have introduced to you the topic very well, they have told you that organic compounds have carbon. And they have told you that inorganic ones, most of them don't have what? Carbon. So carbon is the separating guy for the compounds. So the same thing comes in here in biology, that the chemicals of life we are going to look at, some are going to be organic and the others are going to be what? Inorganic. Are we together? And they are telling you that the inorganic ones, as I've said, that the organic ones, let me begin with organic. What you need to appreciate first and foremost is that they are complex. I introduced organic chemistry to you all very well, and we saw how this carbon is so unique that it can form long chains with itself, but with even other atoms. So that means in the due course, it can form a very complex structure. So they are telling you those complex compounds of carbon. For example, carbohydrate. Someone may be like, now, how do carbohydrates look like? I told you in the previous class that have the application called Pinterest. It will be helping us with images, especially where you're confused as a student. So make sure you have this app in your phone to provide you with such images, so that when you ask for the structure of carbohydrate, they're going to bring for you a certain graphical structure with a lot of carbon atoms linked together and with other atoms. So that makes it complex. So even fats, okay, we have fats here, we have proteins, they are talking of nucleic acids here also. And those are the things we are also supposed to cover in the topic. So have it all learn here that organic chemicals of life, because of organic there is carbon. Because carbon can form very long chains with itself and other atoms, chances are high that the compounds we shall form shall be complex, with every complex structures. Even so that carbon can turn into rings. Think all that is remembered, okay? Then the inorganic ones shall be the reverse. But I want you to listen carefully. So with the inorganic ones, it is two-way. There are those that are going to be completely lacking the carbon. That's why they are telling you that all compounds lacking carbon are going to be called inorganic. But then there are those simple compounds we have. You look at carbon dioxide. Yeah, let me give you an example of carbon dioxide. When you look at carbon dioxide, it is not so complex. So this word complex is so important. So someone may be like, so doctor, if you're saying all compounds containing carbon are organic, do you mean that even carbon dioxide is organic? No. For organic, we look at the complexity of the structure being formed. So carbon dioxide is just carbon and oxygen, very simple. So carbon dioxide is inorganic. You learn that. So it is inorganic for the content I've said or for the reasons I've given. Okay. So we can have certain carbon containing compounds or chemicals or what, like carbon dioxide, but they are not organic. Look at the acid called carbonic acid. I also taught it in chemical formulae. Okay, look at it. That is carbonic acid. It is an acid and it has only one carbon. The complex structures we really talk about here, the others with so many carbons, those ones that turn into rings. But now this one is just carbon, hydrogen, and oxygen. So it will be a what? Inorganic. So hope you create that difference and learn it. Okay? In case of anything that is not clear, you raise up your hand and ask. We rectify it before the content becomes more serious. Okay? Now, I think that is done. So they are telling you that inorganic, all compounds that don't have carbon, even those that have, they shouldn't be complex, but they should be simple. They have given you an example of acids, they have given you an example of bases, they have given you an example of salts. They have given you an example of water. It is also inorganic. For water, it is falling under these ones that completely lack carbon. In the future, you will learn a topic in chemistry. It is still senior 5 under equilibrium 1. It is called ionic equilibrium, where you talk about acids and bases. You will be seeing those examples. They have carbon, but they are just simple. They are not complex. So we render them to be inorganic. Okay? Now that is enough. We are having a lot of classifications, but you're supposed to listen so much. So again, if I'm to take you back briefly, we said that chemicals of life are the ones that make up a balanced diet. And you know, a balanced diet has nutrients. It's those nutrients in the right amounts and proportions, okay? That means these chemicals of life are nutrients. If they are nutrients, I told you about them being required in certain amounts for them to really make the body function efficiently, for us to be healthy. I'll use man, okay, to make it more relative. Yeah? Now, they can tell you, fruits are rich in vitamins, so many different vitamins. But if I ask you, if I ask people here, how many of you really, okay, if I ask anyone here that when did they last eat an apple, I may find none. If I ask when did you last have a pear, things like pineapples, things like watermelons, it has been a very good time. So that means you may not need those vitamins every time. But if I ask, when did you last have posha and beans or rice? Some of you are even eating just right now. That means those are things you really need for your body to be functioning. But the other things of fruits that have vitamins, they may not be so important. So that means even when we need them to be part of our diet, they are those we need in very large amounts, and they are those we need in minute amounts or relatively small amounts. Okay? And then you all know, in science or in English, we have these two words. Just because biology practical changed, but we used to have what we call micro and macro anatomy. But I also talk about them when we are revising the practical. But we have this thing of micro, okay? Then we have this thing of macro, not so? Now I'm posing a question. Which one means big? Yeah, which one means big? Which one means big or large, whatsoever? Because we are relating this to amounts. Okay, someone has said it. Macro big. Those who are not hearing, simply join audio. Simply join audio. Click that thing of join audio. Okay, now those nutrients, all those chemicals of life that are going to be needed in big amounts, in large amounts, in relatively large amounts, they are the macro ones, macro. But we have said they are nutrients, okay? Then those that are going to be needed in relatively small amounts, they are the ones we call micro. Okay, sorry for that. Hope we are back. Our network is not so good, but hope you people are praying hard for us not to have any more issues. But let's move. That will improve maybe with time. Okay. Now, I was telling you that since macro, you guys have said macro is big and micro is small. So those we shall need in large amounts shall be the macro, then the others should be the micro. And we agreed they are nutrients. Okay. So you read this, they are saying that chemicals of life needed in bulk, they are the macronutrients. Then those that we need in relatively small amounts shall be the what? The micro. And they are giving us vitamins as the very first example in micro, and I talked about them. Then they are also adding mineral salts. Yeah? Mineral salts, even if you just go to Google, you just tell Google, you tell AI, give me examples of mineral salts needed in diet. You look at them, they'll give you so many. Table salt, that is sodium chloride. We have iodized salt, a lot of things. Then what are the other macro ones? The macro ones, the ones that we need in bulk. It will even take us back to the complex organic chemicals of life. Okay? And you can see they are giving us the carbohydrates, like the portion you take, the fats, okay? The meat you take, proteins, the meat you take, the beans you take, things like that. Those ones, you need them in bulk. That's why you have them on a daily. The others, you need them in relatively small amounts. The fruits, the vegetables, those things. That's why they are just micro. I think that is enough. Then they are saying all chemicals, we are here, all chemical substances, all the raw material for making them comes from the environment. You all know these things are in food, and food is from the environment. Who doesn't know that? So that is just English. There is no content there. So that is the broad introduction about the topic. So I don't know if there are any questions as of now, but I think we can proceed. But that is it. So make sure you know what a chemical of life is. Make sure you know the organic and inorganic. Make sure you know the macro and micro. That is it for now. So the simplest inorganic chemical of life is the water. And it's what we are going to talk about. In the old curriculum, acids were needed, bases were needed, even salts. But in the new curriculum, they just want us to talk about water. And that's what we are going to do. These acids, bases, and salts, you find them in the future. Yeah. So the simplest is water, and it's what we are going to look at. And I told you we are leaving this place when water is done. It is the lesson target, completing water. Then I give you take-home research for lipids. And then we end the class. Okay? Now, water. Hope you know why we are introducing it. So I've told you it is the simplest inorganic. So I think I will even fix this heading there. That inorganic chemicals of life, they're the ones we are going to cover. And the representative for the rest is going to be water for the new curriculum. So they are saying that water is far the most abundant compound of organisms. You're going to see that our body has a lot of water because we have blood, we have tissue fluid, we have a lot of things, especially the blood part, and water is part. We have cells. These cells inside, they have cytoplasm. You get? And cytoplasm is water. So a lot of things, okay? Now, there are these two values that usually confuse people, and they are somehow different in the different textbooks. That's why we are using words like about, words like approximately. So even in assessment, you make good use of those words. So there is what they call your own cell. Your own cell. Sorry, yeah, your own cells, I mean. Then there is what they call your whole body. So your whole body has so many cells. Are we together? You have what we call the liver. The liver has cells they call hepatocytes. We have the nervous system has cells they call neurons, which I'll study them in coordination. You have the pancreas. Why am I even using systems? Let me use normal structures. You have the pancreas. The pancreas has what we call the beta cells that give you insulin. It has what they call the alpha cells, which give you glucagon. Okay, and so many other organs. You have the intestine that has enterocytes, the ones that give you that alkaline fluid that really makes the pH the pH optimum for enzyme activity down there. Okay. Now, those different cells, they are individual ones, but remember you also have your whole body as an individual. So if I'm talking at a cellular level, the individual human cell, the water it's having is 80%. So 80% of the individual human cell is water. When you look at the human cell, those who covered cytology with us at the beginning, you saw the cytoplasm. It is too much. It takes up most of the water. And you know that it's of course the fluid part. But if you read in more detail, you find out that the cytoplasm has a part they call the cytosol, and it is actually the fluid part of the cell. But have it in mind, it is 80%. That's what you need. But then if we go for the whole body, so this whole body is having those individual many cells, the percentage drops to 65, but approximately you find 60, you find 70, even this 80, you'll find 90, you'll find, yeah, you cannot find 70, but take those values, but use those words I've told you. So that is about the algebra of water content. Hope we are together, okay? Now I want every page we finish, I'll be allowing you take a screenshot. So take a screenshot for that. Take a screenshot for that, then we proceed. In case you have a question, raise up your hand, you ask. There are no questions, we shall just be proceeding, okay? Now, about the structure of water, very serious. So I told you the lesson target. People usually ask me for when classes end. Classes end when the lesson targets are done, unless otherwise. So the water, we are supposed to dust it, so the whole of it. Then, of course, research. Of course, we need to know our next stop. So this being an introductory lesson for the topic chemicals of life, that's why it's free. But the rest of the things to come, lipids, proteins, and so on, those ones will be strictly premium. Yeah, so I don't want you to ask me, why don't we have this one on YouTube? We don't have it because it is strictly and strictly premium, because that's what the management will have suggested, okay? Now, at least all of you are here know the structure of water or the chemical formula of water, that is, it is H2O. At least no one can ask that. So when you see H2O, I can first divide it as follows, that we are having H2O, then O, if I'm just to split. So we are calling these ones two hydrogen atoms. You can even just say two hydrogens. If at all you don't trust your chemistry, then you say one oxygen. Yeah? But to be more safe, two hydrogen atoms, one oxygen atom, like that. So I also put here atom in brackets. So it's better we call them hydrogen atoms. So what I'm going to explain is the most important thing. And whatever we are going to be explaining that relates to water is going to be relating to whatever I'm going to put on this very page. So I beg, in whatever you're planning not to understand from this class, let this one be out. Whatever I'm going to explain just right now, just make sure you get the whole of it. I beg. So this is, okay. Please make sure you understand this part. So we are saying H2O, H2 for two hydrogens or for simply one oxygen atom. I want you to listen. Okay, now this simply means that we are having only and only one oxygen atom like this. Then the hydrogen atoms are two. So we are having hydrogen here and hydrogen here. I want you to follow because things are going to be changing each and every time. Now, I know some of you have not given the periodic table time yet. and that is very bad because I advise you to cover it by this time because I was avoiding such cases that may really give you a time unnecessarily. Now, when you open the periodic table, you'll find out that, okay, let me not say if you open the periodic table. Let me ask people, how many electrons do you think does oxygen have in its outermost energy level? I know you're hearing these words for the first time, and sorry for that. I know you're hearing the word periodic table for the first time. You're hearing the word energy levels for the first time. Even some of your electrons, you've just had them, which is very okay and very normal, but quite absurd. But thank God it is as early as this. But I'm going to see how best we can have it and take the point home. There is something you really need to understand. But I tried my level best to explain it in organic chemistry. But some of you never covered those classes, so I believe you may not relate to what I'm really talking about. But let me say something. Let me show you. Let me show you something here. Let me bring the periodic table. I have nothing to do. This is an academy. With an academy, we teach you everything. So I need the short period. Okay, they don't have it here. Let me bring it. Yeah, just a minute. You really need to learn this from first principles and teach your other friends. You see someone is saying 4 electrons, and that is very wrong. So that means that will affect your structure. So let's try our level best. When we get it, well and good. When we don't get it, maybe next time, okay? Maybe next time. Now, I don't know if the screen is very clear. Let me share it again, sorry. Let me hope those people who have shared their videos are not interrupting us. Okay? I'm seeing someone laughing called Kim. I don't know what's funny. I don't know if people are already running mad as early as week 2 of senior 5 term 1. Okay? Now, you look at this periodic table because you need it. And in O level, you were studying period 2. So I believe you know what I mean. So these values you're seeing, these ones are the groups. Group 1, Group 2, Group 3, Group 4, Group 5, Group 6, Group 7, Group 8. Okay? Now, I'm going to simplify your life for now. Allow me simplify your life for now and simply tell you that these ones, yes, are the groups because you will need that information. Someone may be like, what do these groups really represent? They are there to show us the number of outermost electrons. They're there to show us the number of outermost electrons. That if something is in group 3, that means it's having 3 of them. Someone may be like, now what is the word outermost? What do you even mean by that? There are some of you even don't know the word or the meaning of the word electrons. That means I will request you to go to, we don't have that lesson on YouTube, but there are lessons of electronic configuration. They really bring out these things so well. But for now, you just understand the English, that electrons, at least you know them. Because I believe people here know the structure of an atom. That an atom is having a nucleus in the middle, then around it's having what they call an energy level. You learn that at least. Then have it in mind that in the nucleus we have protons and neutrons. Then in this energy level revolving around, the one we call the orbit, that's where we have the electrons trying to evolve, trying to rotate. I believe you've heard of that. And then you should know that electrons carry a negative charge, protons carry a positive charge, and these neutrons carry no charge. Remember, this one is the nucleus. So I think you see why they call the nucleus positively charged. Because it's having protons which have a positive charge and neutrons which carry no charge. Then the orbit around is what they call the energy level, what they call the orbit, and it's the one that carries electrons, and electrons carry a negative charge. At least learn that. So these figures, group 4 simply means there are 4 electrons outside. Group 5 simply means there are 5 electrons outside. Group 8 means there are 8 electrons outside. Group 1 means it's 1 electron outside. So for today, we are studying hydrogen and oxygen. So you should know that the symbol of hydrogen is H and that of oxygen is O. So those are the letters we are going to look for, H and O. When you look for hydrogen, we shall see it here, H. When you look for oxygen, we shall find it here, and it is here in group 6. This first hydrogen is in group 1, the oxygen is in group 6. I think you can see that. Someone may be like, but I'm seeing hydrogen again here under group 7. That was also taught. You go and check that lesson. It is on YouTube. The one that says periodic table lesson 1. I taught you the uniqueness of hydrogen, that it belongs to both groups 1 and 7, and we explained all that content. So I'll refer you there. But for now, we are taking hydrogen and oxygen the way they are. 1 electron outside and 6 electrons outside for oxygen, 1 electron outside for hydrogen. So first understand that only. Is it okay? So when I come back to our workbook, we are saying that this oxygen, this one, I'm only interested in the outside. We're saying that this hydrogen is like that, and outside it's having only 1 electron. This one is also hydrogen, and we are saying it's having only that electron. Are we together? But then when we come to this, okay, hydrogen, only one like that. Even this hydrogen, it's having only and only, sorry, 1 electron. It's what I mean. Oxygen, we have said there are 6. I've told you the property or anything that I'm explaining right now is the one we are going to relate to all the things that are going to come in the future. Things of cohesion, things of adhesion, things of viscosity, everything is going to be relating to this. So help me one thing, stay alert and get the point of polarity. Now, the oxygen is having 6 of them outside for reasons I've given you. So I'm going to say these ones. Remember, electrons can occur in pairs. I don't know if they taught you what they call the Pauli's exclusive principle. I don't know. The one that talks about the pairs. I don't know for now, but those things we taught all of them, okay? Then these are 4. We say they are 6. So we can have 1, we can have 1. Then the other thing that I also want to teach you today, that I've also always taught you, it is one problem that I usually find with these classes. So you will forgive me for those that I leave behind, or those that I waste time for. These being free classes, there are concepts I'm not sure whether some students visited them or others never. So I'll be leaving out some concepts and also going deeper for some simpler concepts. But you need to bear with us. This is an academy, everything is taught. This is not a school. So this is hydrogen, and hydrogen is a non-metal. You cannot tell me it's a metal. Even the oxygen, we all know it's a non-metal. So this one is a non-metal. Even these hydrogens, they are non-metals. I want you to listen. Even this one is a non-metal. Okay. Now, if at all we want to form the water, we want to have the H2O, we want the hydrogen to interact with oxygen, but remember both are non-metals. My question is, if they are to bond, but both of them are non-metals, which kind of bond is going to exist between them? Is it going to be an ionic bond? Is it going to be a dative bond? Is it going to be a covalent bond? Which bond exactly are we going to get? We have seen the H alone and the O alone. We have looked at their structures in terms of the number of the outermost electrons. We have appreciated the fact that both are non-metals. So the question is, if they are to bond, which kind of bond is going to exist between them? Is the bond going to be ionic? Is it going to be divalent? Is it going to be covalent? Which kind of bond exactly? Okay, let me see. You see someone is saying ionic, that is bad. It's going to be covalent, because covalent is the one that exists between nonmetals only. The ionic, that one is in metal and non-metal. So you listen and get this. If at all you're dealing with non-metal and non-metal, I told you these things in Introduction of Organic Chemistry, where we are looking at carbon and hydrogen, and both of them were non-metals. Then we say the bond between carbon and hydrogen is covalent. Why? Carbon is non-metal, hydrogen is non-metal. So you learn that. You learn that, please. You learn that, please. So something is going to happen. Something is going to happen. Then also, I have a simple question for you all. If at all, okay, where do we have sharing of electrons? Do we have sharing of electrons as we form the ionic type of bond or the covalent type of bond? This is chemistry that is going to help you understand this topic. Remember, it is chemicals of life. You cannot escape chemistry. Even if you do what, you can't. After all, their study is biochemistry, so it is biology in chemistry. So what do you think? Do we have, where do we have sharing? Where do we have sharing? Okay, people are trying. They are saying covalent. But don't worry, we shall look at all these things in the future. Yeah, we shall look at all these things in the future. But let me give you some small hint. Yeah, just a hint that can maybe help you in one way or the other. There is when we shall have a positive somewhere and then a negative somewhere, okay? Now, in physics, there is a topic they call electrostatics, which they even talk about in all levels. So don't say, but we don't do physics. It is cheap, where they talk about opposite charges. So when this is positive and this is negative, there is always that force of attraction, the force that attracts the two. That force is called the electrostatic force of attraction. So that electrostatic force of attraction, in the moment it comes in chemistry, this type of bond is what they call the ionic bond. Okay? And then we shall see where the positive comes from and where the negative comes from. We shall see all that. So where these ones are not existing, chances are high that it will be a covalent bond. So understand that for ionic, you people, you know ions. You go to that lesson of chemical formulae, look for where I taught the structure of an ion. You will see that an ion is either positive ion or negative ion. So the attraction between those two ions creates that electrostatic force of attraction. And that's what they call the ionic bond. What is a covalent bond? The covalent bond is when this one is absent. Yeah. So when this is absent, that means chances are high that we may have a covalent bond. But now, how are we really going to have it? Let me teach you. You people, look at this word, covalent. So you understand it from covalent. Don't say structure and bonding is a hard topic. When you hear the word ionic bond, you tell the teacher that means ions, and ions are either positive or negative. And the positive attracts negative. So that force of attraction, that electrostatic force of attraction is what they call the ionic bond. Then the teacher will ask you what of covalent. So you tell your teacher, I'm seeing two words, that is co and valent. Then you tell your teacher that the word valent or valent alone, I'm going to say valency electrons. And the teacher will ask you, what are valency electrons? Then tell your teacher that valency electrons, we can also call them outermost electrons. Are we together? Then you will have a balance of this one, the co. Then you tell your teacher, what does a co-wife mean? Or the term co-wife, what does it mean? You tell them that co-wives are simply two women sharing a man. So every time you see the word co in English, think of sharing. Co-wives are two women sharing a man. So when you see covalent, that means you like it or not, we are sharing. We are sharing what we call valency electrons. And valency electrons are the outermost, which we get from the group which group we get from top of the periodic table, which periodic table is always provided. So what is hard here? Nothing. Okay. Now, after understanding that in a covalent bond we are going to be sharing valency electrons, the question is, how is sharing done? How is sharing done? How is sharing done? Most of you know what I mean by sharing. That if they give you a chapati and they tell you to share with a friend, we expect you to share equally. Okay? If at all they give you anything to share, okay, we expect equality in sharing, if I may say. Now, if at all we've agreed that non-metal and non-metal, it's a covalent bond, and we have said a covalent bond comes from sharing, and what we are sharing are valency electrons, or the outermost electrons, and we've added that sharing should be equal. This thing is so important. There should be equality in sharing. What I mean is this. What I mean is this by equality. Someone will be like, what do you mean by equality? By equality, I mean if X and Y claim that they are going to bond together covalently, that there is a covalent bond between them. As a student of biochemistry, as a student of chemistry, the moment you realize it's a covalent, you just know that X alone is a non-metal. Please give this concept of polarity time. Give it time. So you listen. Even Y is a non-metal. So we have said there should be equality as electrons are being shared. What do I mean? That if X brings one electron, remember all of them have electrons, even Y brings one electron. Are you getting the point? Then if X brings 2 electrons, even Y will bring 2 electrons. If X brings 3 electrons, even Y will bring how many? 3 electrons. So understand that. Covalent, we are sharing outermost electrons. Sharing, we should have equality. If X brings 3, even Y will bring 3. Are you listening? If X brings 2, even Y 2. Now, let us form the covalent bond between oxygen and hydrogen. Because remember, you want to come up with the water. Remember the section competence, that you should analyze the property, which we are doing, and then we should relate it to the functions. That means without you understanding properly the properties, the structure, you won't understand the what? The function. So you listen. If at all oxygen decides to bring 1, even hydrogen can bring that 1. The problem is oxygen wanting to share 2. Because if oxygen brings 2, even hydrogen should bring 2, but it doesn't have the 2. Hydrogen only has 1. That means oxygen has no option other than allowing the hydrogen to bring 1. Because if it brings 2, it is giving hydrogen a task of also bringing 2 because of the equality in sharing. But then it doesn't have them, it has only 1. So that means oxygen will have no option other than delivering only this one, so that even hydrogen can deliver this one, and they come together. We are going to see what I meant by sharing. Then also oxygen will give off this one so that even hydrogen brings this, and then they do what? They share. I know whether we are together, people. Hope you know why oxygen is bringing 1. Because if it brings 2, it will task hydrogen, or it will have tasked hydrogen to bring 2, which it doesn't have. So it's supposed to be 1 for oxygen so that hydrogen also brings. So what is the resultant? This is what we get. This is what we get. So we are going to have something like this. We are going to have, let me show you here. This is what is going to result. We are going to have Please turn over. I explained this well. Okay, so we are going to have this as the oxygen. So we all know these ones have stayed, this one stayed, this one stayed. Not so. Then we all know that the hydrogen came. We also know the hydrogen what? The hydrogen came. So what do we have here? We are having the oxygen in the middle. We are having H. We are having H. Okay. The hydrogen each came with its E. Each came with its E. Then also the oxygen came with what? Came with this. Came with this. Okay. Now there are things that they will teach about stability, but have it in mind after they have shared like that. This one is now a stable compound. Yeah, it is very stable. It has attained stability, very stable after that sharing happening. And you all know it's like that. Okay? Now, this one has a different way of showing it. Now, this is cartoon. This is cartoon. For us, we are interested in the chemistry. So I'm going to turn that one into bonds. So here where sharing has happened, that's what they call a covalent bond. Though it looks like an intersection set, but it's a covalent bond because that's where sharing has happened. Even this one, the same thing. It's a covalent what? It's a covalent bond. Now, how do I turn this one into chemistry? Because I've told you that is cartoon. I'm going to put the oxygen atom here. Are you listening? Then I'm going to put the hydrogen here. I'm going to put the hydrogen here. Okay. Then I'll put that bond as the covalent bond, even this one as the covalent bond. Are we together? But remember, we are having these ones, these electrons are still here. Yes, there is this one, there is also this one. So what I will do, I'll put them on top together. But this time around, I'm going to use dots. Remember, electrons, you can use E, you can use X, you can use a dot. Since now I'm turning it into real chemistry, I'll use dots. So I'm going to put the first pair here, and then I'm also going to put the second pair here. You're going to understand by force. Now, there is something that I really don't want you to forget, that these lines are the covalent bonds. I've just converted them from the intersection set format to the line format. So they are still covalent bonds. Are we together? But if you analyze well, this covalent bond is having 2 electrons. Are we together? Even this covalent bond is just made up of 2 electrons, where oxygen brought 1 and hydrogen 1. So it's called a bond, but it's having electrons. I want you to listen to that. Now, I'm going to put here also 2 dots to mean the 2 electrons. They are here hiding, 2 of them. Even here, I'm going to put them, 2 of them, 2 of them. Let me tell you, most of you here know that water looks like this, but some of you are not aware. You don't know why. Why is it even like that? So it's what I'm trying to explain. This being an academy, you're supposed to understand this thing, okay? Now, you all know that I want you to fill this space for me. I said that one is stable, so I want you to fill this space for me. I'm going to say electrons dash electrons. You tell me, should I put the word repel or attract? Electrons and electrons. What should I put there? Attract or repel? What do electrons do to electrons? Do they attract or repel? I want to see people participating. Okay, most of you have passed it. Most of you have said repel, and that is good. We all know unlike charges, unlike pose, attract. Like charges, like pose, attract. Sorry, repel. Sorry. Like, repel. Unlike, attract. Okay? Yeah. Under normal circumstances, a girl is supposed to attract a boy. Yes. Now, because they are unlike gender. So we expect attraction under normal circumstances. Now, look here. Remember, these ones are electrons, even these ones are electrons, okay? So there is going to be repulsion, you like it or not. These ones are electrons on top of the oxygen, even these ones are electrons in the covalent bond. So there is going to be what? Repulsion like that. In chemistry, I will teach you that those ones are called bonding pairs, the ones in the covalent bond, and the others on top of oxygen, the ones that weren't shared, I will teach you that they are called lone pairs of electrons, and we are also going to see them in the diagrams we have. The ones on top of oxygen weren't shared, so they are lone pairs of electrons. These ones inside the covalent bond, they are inside the bond, so they are called bonding electrons or bonding pairs of electrons, whatever. But I will repeat that because we have students of PCM, so they will need to learn that because this is being said in biology. So when this one happens, this is what is going to be the result. You see the repulsion? So the repulsion will make this bond to bend, even this bond to bend. So someone may ask, it is bending until when? That should be the question. That should be the question. Now, I want to teach you something because in the future you will still need it. Someone may ask, yes, the repulsion is happening and the bending is happening, but until when? Should it really bend until it's like this? Not really. It bends until we reach somewhere, and we can only measure this one in terms of an angle. So this one is an angle, and it is a certain angle. And since it is an angle between bonds, it is called the bond angle. So there is a certain value of the bond angle where we are supposed to stop, or where the repulsion stops, or beyond which the repulsion cannot really cause any further change. So go to the internet right now. You really need to learn how the internet is used in academics. You can ask Google, what is the bond angle in water? You tell me the value you're getting in the chat. You go to Google, ask it, what is the bond angle in water? So in case you want to learn the bond angles in the different structures that you will learn to draw in the near future, ask yourself, or how do you need to ask the internet, what is the bond angle in this? What is the bond angle in this? Like that. So ask Google, what is the bond angle in water or of water? Tell me the value you're getting. You're getting 104, you're getting 104. But the textbooks of biology have 105. You will find 106. You will find 103. You will find so many values. That's why I told you that for values in science, we always use the word about, the word approximately, words like that. So the bending is going to happen until when we reach the obtuse angle 105 degrees. The moment we hit about that, that's where we shall stop, and we shall have obtained a perfect structure of water. So as you're drawing the structure of water, I beg, let the bends be present, let the two hydrogens be present, let the bonds be touching, and don't forget to show two pairs. Hope you know why there are two pairs. Most people forget and only show one pair, and they end up failing. But at least you have an explanation as to why, even when you've forgotten the explanation, but at least you believe if you read, you can recall. That is all. I told you when they introduce a topic or when you learn something for the first time, you've not understood, you've appreciated. When you go back and read, you're now understanding. When you read again, you're slowly mastering until it really becomes part of you. So that is it. So that is the structure of water. But let me tell you, it does not stop here. Now we are supposed to relate this structure to polarity. Let me tell you, the moment we get done with polarity, and you people be like, yeah, polarity we have understood, that will be very okay. Yes, you'll be good to go. The moment you understand polarity, then you understand hydrogen bonding. That is all. Now you know how the structure looks like. Now I want to teach you what they call polarity, so that you also learn it. So that you also learn it. But in case it really gives you a time, there is a topic in chemistry that is called periodicity 1. It has the first topic, periodic table. Now, periodic table has lesson 2. Now, it is in lesson 2 where we explained all those properties, and I will send you there for you to get that concept well. Here, I'm going to just talk about it briefly, but in a way that is really going to favor us all, because I believe people tomorrow have to go to school. Okay? But let's cover work. Let's cover work. What is that thing that I want to talk about? What is that thing that I want to talk about? There is what they call electronegativity. And I also taught it in organic chemistry introduction, but people didn't give it time. But there is what they call electronegativity. Let me do this for you. So that you learn something today. Okay? Because now you're not supposed to just understand things in a funny way. But let me give anyone a chance. But I'm giving you just a minute. I'm not giving you a lot of time. Who can really say something small about electronegativity? Who can say something small about it? Anyone who has been really listening to the classes and taking notes? Do I have any premium student here to give us their view, or anyone? Because now electronegativity is supposed to be explained in details in chemistry, but now we are in biology. But you need it. Let me tell you, new curriculum content became hard. And with biology, don't cram everything. You have a lot to cram. So the little work you can understand, try your level best to understand. So do I have anyone? Don't go to the internet. Whatever the internet will tell you, you will not understand. Okay? Anyone to say something small about electronegativity? I'm giving a chance to only one person. Okay, Joshua, say something, we proceed.
Good evening, everyone. For what I know about electronegativity, I will give an example of an oxygen atom. So electronegativity means that that atom receives electrons during bonding. So that's what I know.
Yes, you tell me, when it receives electrons, what happens? That's what I want. What happens?
Oh, for
Eh,
example, so that when it receives electrons, it becomes partially negative.
okay, that is good.
Yes, that's what I know.
Okay, that is good. Okay, that is a very good try. I always want to give people a chance to say something so that even people can have a break. Hope that was a short break and so important. Okay. Now, with electronegativity, maybe let's look at maybe two people, because we talked of sharing electrons. You people saw that. So we saw X and Y trying to covalent bond and sharing electrons. Now, let's look at X and Y. Let's first look at them maybe as people. So these ones are people, and they are sharing food. They are sharing food. Okay. But it turns out that X is more greedy. I want you to listen. More greedy. Then, of course, Y is the opposite. After saying more greedy, that means we have, of course, compared with Y. So this one is, okay, more greedy. So because X is more greedy, that means we'll eat more. Then, of course, this one, it will be less food. What will be the result? This one will be satisfied. And then this one will be left angry. At least that is very clear. That is just normal English. Now, what if X and Y are sharing electrons? Now we are going to change the story to electrons. We see. And just get it like that. Don't ask me a lot of questions. You're going to just get it like that. So what if X and Y are sharing electrons? I gave you the directions of the lesson. You may need to get it in details. But let's get a concept that really makes us understand the biology we need now. Now, we are changing our food to electrons, okay? Now, the grid we have been talking about there is our electronegativity. You learn it. So the grid I've been explaining is our electronegativity. It's our electronegativity, okay? Now, assuming that X and Y are sharing electrons, I want you to see what happens because it's what we need to really understand all the biology that is coming next. Yeah, you miss this property of polarity, you're gone. X and Y are sharing electrons. But we have said X is more greedy. But of course, we said greedy means that X is more electronegative. And since it is more greedy, remember they are sharing electrons. So that means X tends to take the electrons more towards itself. Just like the way you can be sharing food on one plate. Because you're greedy, you try to push all the rice towards your end where you're eating from. Look at it like that. So X tends to take the electrons more towards itself. Because it is more greedy, it is more electronegative. More towards itself. Okay? Then Y will be the opposite. So for the case of Y, right, it is less. This is greedy. It is less greedy. And we have agreed by less greedy, we mean less electronegative. Okay? Because the other one is taking the electrons more towards itself, that means this one tends to lose. You get it? Y tends to lose the food. Y tends to lose the electrons. Hope we are together. Stay on track. Okay, now remember, we said that someone called Juma, leave our screen. I'll remove you from the meeting. So please kindly behave. So we said that electrons carry a negative charge. And remember, we are saying tends. This word is so important. Tends. Someone may be like, why are you really saying tends? So electronegativity is a tendency. Yeah. You need to know that in chemistry. It is just a tendency that is going to give us very good results. But I want you to listen. It is the tendency. Okay? Now, you tend to be greedy and then eat your friend's food. So even here, electrons, the greed is just a tendency. The electronegativity is a tendency. And it is taking the electrons more towards itself. But remember, these electrons carry a negative charge. I want you to listen. Now, because this X is taking electrons which carry a negative charge more towards itself, the X may end up getting a negative charge. Listen. What happens next? X gets a dash negative charge. This is the best way you can understand this. So do you understand where the negative is coming from? It is coming from the fact that these electrons X is being greedy on carry a negative charge. So if it is too greedy on them, it may end up getting that charge. But since it was just a tendency, the charge is not complete. The charge is just partial. So because of the word tendency, even the charge we get is not serious. It's just partial. Partial negative charge. How do we write partial negative charge in science? We write this one as the symbol of partial and we add negative. I believe if at all they taught you this topic, that thing was written somewhere. So you need to know how it came about. And that's how it came about. You can see the negative, then the other delta sign, it is a Greek letter. It's the one trying to show us partial. Okay? Then of course the reverse will be true for the y. So the y in the end for it will end up with what? With the partial positive like that. Anyway, the people are getting. X and Y are people, they are sharing food, but X is more greedy. So X eats more food and they become satisfied, but Y is left hungry. What if the food becomes electrons? X will still will be more greedy on them. So it will tend as if it wants to do what? To take those electrons. But remember, electrons carry a negative charge. So we can't get surprised when we see X starting to get a negative charge. Because it is being greedy on what carries a what? A negative charge. But since it is just a tendency, that charge may not be full, just partial. Okay? And since X has gone off with the partial negative charge, it will leave Y with no alternative other than going off with the partial positive what? Charge. Are we together? Someone may be like, in the first place, why are they sharing electrons? They are sharing electrons because they are joined or linked via a covalent link or covalent bond. Are we together? Those who follow those classes of introduction, I think now the point has been more understood. Okay? Now, this is what happens. This is what happens. Hence, before I even write the hence part, I want only 10 people out of the number that is here to confirm to me that the point of partial positive and partial negative, the point has been driven home. Because now we are done. That is all you need to understand, nothing more. Nothing more. You just tell me in the chat that partial negative, partial positive, okay. Don't send no if you had issues with network. I'm talking to those who have been on full time. Should you go to the hence part? Is this the meaning of electronegativity, please? Okay. Now, electronegativity for it is the tendency to take electrons more towards yourself. That is the greed of taking the food still more towards yourself. As I explained, if at all you're eating and sharing a plate, if you've been following, I think the point is clear. Now, what is the hence part? The hence part is that we are going to come up with two things. We are going to come up with X. We are going to come up with Y. Are we together? Now, we have said that X is going to have a partial negative charge for reasons you know. Then this one is going to have a partial positive charge. Okay? Now, this one is what I'm going to call a positive pole. This is what I'm going to call a positive pole. And then I'm going to call this one a negative pole. Are we together? Now, the existence of these two, hey, the existence of the two, so I'm going to say existence of the two, this is what you need for tonight, and then you log off. Existence of the two is what they call polarity. Let me tell you, for you may look at it as something simple here, but if they tell you to explain the existence of polarity, it may be hard. Because now you're supposed to talk about negative pole, positive pole. How does the negative pole come about? How does the positive pole come about? You need to be knowing those things. Why do they really pull themselves? Because they have a difference in electronegativity. One is more greedy than the other. Okay? Yet they have been sharing in the first place. Things like that. Now there is something else that you really need to learn. There is something else that you really need to learn here. Okay. Now, if I told you you're having so many, if I told you you're having so many, if I told you you're having so many XY molecules, what is going to happen? If I told you you're having so many XY molecules, what do I mean? You're having X and Y here, okay? You're having X and Y here. You need to get this, okay? You're having X and Y here, things like that. I'm going to show, I've said so many, but I'm going to put 3 as the representative, okay? Then maybe you have XY here. Let me also put here XY, okay? So many. Now we all know that X is what? Partial negative, okay? Partial positive. Partial negative, partial positive. Partial negative, partial positive, partial negative, partial positive, partial positive, is partial negative. Are we together? Now, there is something that is going to happen. Don't think we are going to just stop there. And yet the positive and negatives are looking at each other. The moment this positive looks at this negative, you like it or not, they are going to interact. The moment this negative sees this positive, because they are oppositely charged, the moment a boy sees a girl, in one way or the other, they may try to approach them. In case a predator sees prey, a lion sees an antelope, it is supposed to attack because they are unlike. And you know about attraction between two unlike things. They are supposed to do what? To interact. The moment this positive sees this negative, there is supposed to be what? An interaction. Are we together? The moment this one sees, which one else? This one, negative, they're supposed to be what? An interaction. Let me hope we are together there. So I'm going to explain this one further later. I'm going to explain it when? Later. Now, this one in chemistry, as I was teaching you that topic, we called them the Van der Waals forces of attraction. And also you learn it today. You need it. These ones are the covalent bonds. Everyone knows that. Covalent bond, C and between X and Y. Covalent bond, everyone knows that. Now these other ones, the dotted ones, they are the weak Van der Waals forces of attraction. They are the Van der Waals, weak Van der Waals forces of attraction. That one was explained, but you may not need it now. What you need is something else. Now we are supposed to relate all this to water. The moment you understand that of water, you're just good to go. You're just good to go. You're just good to go. So if I'm to relate this to water, you're going to see the polarity, you're going to see those bonds. And it is those bonds that are talked about throughout in the properties of water, nothing else. And it is the properties of water that really make all these things fun. Or it's the properties of water that end the topic. You understand them, you've understood the topic. So please turn over for the water. Now let us relate it to the water. Where are the partial positives? Where are the partial negatives? Things like that. Where are the Van der Waals? Where are the covalent bonds? Things like that. So now we are from the XY. We want to relate to water because it is what we are supposed to cover. So let's relate this to the water. Okay. Now, if you're to relate to the water, you're going to have this. You're going to have your hydrogens here. You're going to have your hydrogens here. I believe you people know the bond angle, even if I don't show the bond angle like that. Okay. Now, you people, I believe you are aware, and you can just look at the two. You people, you think of oxygen and hydrogen. Who do you think is really more greedy here? You tell me. You can just look at them. You can just look at them. In most of the cases, the greedy people are the people who are better than you because they really want to get better. Yeah. It is the people who have money that do corruption. That's why you can never hear corruption within poor people because it involves bribery that involves money. So if you don't have money, then corruption can't be your friend. So it's always the big people that are really greedy. So of oxygen and hydrogen, it's like asking who is bigger. Who is the big brother here of oxygen and hydrogen? The big brother is the more greedy one, oxygen. So if oxygen is more greedy, we expect it to take away the electrons they are sharing here, to have that. Remember, this is a bond, but there are 2 electrons there. Hope you recall. So oxygen has the greater tendency of stealing them, of putting them more towards itself. But remember, electrons carry a negative what? Negative charge. So never forget these lone pairs. So I don't want anyone to be surprised when I put partial negative on top of oxygen, because we have agreed it is the big brother here. It is the one that is more greedy, because it's the people on top that always want to get more. Okay? Then that means the hydrogen will be left with no option other than being what? Partial positive, other than being what? Partial positive. Are we together? Now, the structure, drawing the structure like that, it is not something easy to put those charges. If at all you've understood the explanation concerning those charges, you will understand the hardest topics in biology, because this is the second hardest after genetics. After genetics, the next hardest thing to understand is the polarity of the water molecule. And it is its polarity that really defines the rest of the things. The rest of the things. Okay? Now, after understanding that, I'm going to first stop there. But you all know that this one is a covalent bond. You all know this one is the covalent what? Covalent bond. But at least appreciate those partial what. That simply means the oxygen atom is more electronegative. And for that one, I'm done. Now, the other important thing. Let me ask you people. If I put, you can put water in a cup, and you can also put water in a basin. If I put water in a basin, does it mean it is one big water molecule? Okay, put water in a cup, put water in a basin. What is the correct thing? Is it that it is one molecule of water in each of them just because the one in the basin is bigger, or there are many water molecules just because those in the basin are more? Are people getting the question? The question is concerning size and number. Have put water in a basin, have put water in a cup. The one in a cup is little water, the other one is more. What is the correct science behind? Is it that it is one water molecule in each just because the one in the basin is bigger, or it is difference in number, that the water molecules in the basin are more than those in the cup? Which one is the right explanation concerning size, concerning number? So you just write number or size in the chat, because you really need to know that. Someone may be like, if at all it is about size, why are you bringing certain ideas? Did the people really listen to my question? Because people are not answering in the chat. Only 3 people have answered, and they have said number. And you people, that is it. Because I think the mere fact some are not responding, they are not sure. So you learn. It's not about the size of the water molecule. It is actually more water molecules, okay? So that is just a by that. I'm not going to write it. So what happens if we have many water molecules? So hope everyone has listened to that. Okay? Now, when we have so many water molecules, this is what is going to happen. You're having O, then H, and H. Is it okay? Then even here you're having O, you're having H, you're having H. Are we together? Even here you're having O, you're having H, you're having H. Okay? Even here you're having O, you have H and H. In any way, they can have any format. Or you have H and H, provided you show the bond angle. It's so important. Let me only show those ones, okay? Now, deep down, you should know, as a biologist, as a biochemist, that we have partial negative. On top of that O, partial negative. One thing you're not supposed to forget are those lone pairs of electrons on the O. Can put like that. So I'm going to just use dots to save time. Dot like that. It is this property that we base on to explain all other things in water. The moment you have issues with the property, then that means you may really find it hard, okay? So that is the water molecule. Then you know that the hydrogens, those ones are partial positive, partial positive. So you come and also show partial positive, and put them anywhere, partial positive. So that's how the water molecules look like in a cup. That's how they look like in a basin. So when you look at them, you should have a different view from a student who doesn't do biology. Okay, I think that is it. Now, I told you that the negative cannot just look at a positive in science. Never. The moment they look at each other, they do what? They interact. The moment a positive sees a negative, they do what? They interact. The moment a negative sees a positive, they do what? They interact. The moment negative sees a positive, they do what? They interact. They interact. And so many other interactions and so on, okay? Now, these interactions, I told you they are Van der Waals forces of attraction, which is correct. But these ones are special. What really makes them special is that all of them involve hydrogen. Even this one is involving hydrogen. Even this one is involving hydrogen. Even this one is involving hydrogen. So because of that special involvement of hydrogen in the formation of these Van der Waals forces of attraction, we give them a special name. And that special name is hydrogen bond. Hydrogen what? Hydrogen what? Hydrogen bond. So as a scholar of Science Scholars Academy, I expect you, if at all they tell you to explain how the hydrogen bond comes about, I expect you to begin from the point of polarity. Explain polarity very well. After there, tell people about how water means so many water molecules together. Show them how the Van der Waals come about. Tell them that hydrogen bonds are special Van der Waals forces of attraction. Few students in the country can explain what we have just explained. Don't just take it for granted. That hydrogen bond. There is a statement we read here in the syllabus book that said thermal properties of water are not required. But those thermal properties of water, all of them were related to the structure of water we have just talked about. And you need it. These are concepts you will appreciate when you reach the future. All of you are going to have biology somewhere in your future courses. There are things you'll never escape. So when you have a very good foundation, those things in the future become very nice and very easy. Okay? Now, that is the hydrogen bond. Hope you're not asking me any questions. Now, I told you about the existence of polarity. You understand? So because we have a negative pole here and a positive pole here, we end up saying that this bond is polar. You understand? Yes, we can call that a polar bond. So we shall also see that. So polar bond, it is just a bond connecting two things where each has a pole, negative and positive pole. Yeah? Polarity pole, polar. Polarity pole, polar. They are just related. Yeah? So nothing much there. Okay? And now you've also looked at the hydrogen bonds and how they look like. The other thing I really want to add on is that remember, this one is we have said that this one is a polar bond. Okay? You understand? Even this one, a polar bond. So you will find somewhere people telling you that water exists, it is in Fa. It exists as a dipole molecule. By dipole, they are telling it's having two poles. And you can see that, or two polar bonds. Each of the bonds is polar. So dipole. So when you see dipole being written somewhere and it is relating to water, understand, you can see one side positive negative pole, even the other side negative positive pole. Yeah, this is what I mean. You have O, you have H, you have H. This one gave us positive negative pole, even here positive negative pole. Yeah, so you can see that dipolarity. We can just say OH is one bond and polar, another OH is another bond and polar, so dipole. Eh? So when you see that word, don't say doctor didn't tell us, I have told you. Now we are going to go and read through our notes. And trust me, there is nothing. You're not going to see any new things. Most of the things are just like that. And things work out. Okay. Now, Most people ask themselves this. You give me one thing that you use at home and it dissolves in water. Give me that one thing. Give me that one thing that you use at home and it dissolves in water. Give me those things in the chat. As people also rested bit. This is just chemistry, not even biology. Biology I have not yet started speaking. Hope your notebooks are ready. Give me anything. Salt, someone has said salt. Sugar, that is good. Sugar, salt, okay. Let me use salt. The one that is common. Even in FA, that's what they used. So salt. So someone may be like, how does really salt dissolve in water? That's what I want you to learn today. Yeah. You tell me in the chat, what is the chemical name of table salt? The one we use at home, the table salt. What is the chemical name or the chemical formula in the chat? How does salt dissolve in water? You tell me in the chat also, what is the chemical name, chemical formula of table salt we use at home? Yeah, so how does the table salt dissolve in water? That's what I want us to learn today. So you guys have already looked at how water looks like. Yes, we have already looked, you have already looked at that. You know how water behaves and everything. Now, if I told you bring salt, let me see in the chat. People have said it, sodium chloride. Thank you so much. People have said it, sodium chloride. So I'm going to use sodium chloride, but it's going to represent all the rest. So don't expect me to show you this explanation again. So what happens? Have it in mind, sodium chloride is having a sodium ion and chloride ion. Okay? Now, when you see salt alone as salt, that means it is many sodium chloride. It's not only one, yeah? Just like the way you said that in a benzene, it's not one big water molecule. It is just many water molecules. So when you see salts, there are so many sodium chloride what? Compounds, molecules, whatsoever. It's not one. So when there are many, that means even these ions are what? That means even these ions are many. Even these ions are what? Are many. So when these ions are many, remember you are adding them to water. But even in water, the water molecules are what? Are many, and that one you already know. So I'm not so much surprised. So let's show that water. So I'm going to show 4 of them. We have that water. We have the water molecule here. We have another one here. Provided you show the bend, yeah? We have another water molecule here. We have another water molecule here. So I'm only going to show 4 for the interest of time. People will benefit, okay? Now, you all know that we are having the lone pairs on oxygen. Hope people are also taking notes on oxygen like that, on oxygen, on oxygen, on oxygen, on oxygen, okay? Then we all know oxygen has that partial negative. Then these ones have partial positive, partial positive, partial negative, partial positive, partial positive, oh, partial negative, partial positive, partial positive, this one partial negative, partial positive, even this one partial positive, like that. Now, when you bring your sodium chloride, your table salt, and add it to the water, it is going to come, but it's going to come as ions, don't forget. So the ions shall have there maybe one molecule, it will be there, sodium chloride. I'm also going to show 4 of them. Sodium chloride, one here, another one here. Again, maybe let me show chloride, then here down I show sodium. I'm showing 4 of them also. Then here I'm also going to show maybe sodium here, then chloride here. Now you've mixed them. So as a science student, when you add salt to water, I want you to be seeing what I'm saying. Don't see it as a normal person. See it as sodium ions and chloride ions interacting with that funny structure of water. Then have it in mind, a negative can never look at a positive just like that. The moment they see each other, they interact. The moment they see each other, they interact. What do I mean? Let me use green. So you look for green color. Negative C is positive. Do you see that now things are changing a bit? Negative C is positive. Don't be like, but the others are partial charges. Leave the partial alone. Concentrate on positive and negative. They can never see each other and they just stay. Negative C's like that. Are you seeing that? Negative C's positive. Are we together? Negative C's positive. Negative C's. Negative C's positive. Like that. Negative C's. I think I've not left out N. Now, that thing you're seeing, that interaction is the dissolving. A. This interaction you're seeing, it is how they dissolve. The moment they interact, the dissolving happens. So don't ask those questions again. So the reason as to why sugar dissolves in water, you may not know the formula of sugar because it may be a bit complex. But deep down you should know that maybe this sugar forms positive and negatives, which interact with the positives and negatives water already has. So those charges on water are responsible for attracting charges from other compounds, and that attraction, that interaction is the dissolving. Are we together? Are we together, people? So for anything to dissolve in water, this is what we expect. We expect that thing to come with positives and negatives. Why? Water is already having its charges. So when they come, the negative of water on top of oxygen will attract the incoming positive. And then the positive on the hydrogens of water will attract the incoming negative. And that attraction is what they call dissolving. They have interacted, dissolving happens. Okay? And that's what makes water a universal solvent. That most of the things we add water to have the ability to give us the positives and negatives. And the moment they are formed, water comes out with its charges. The negative on oxygen looks for the plus, get in touch. The positives on hydrogen look for the negative charges, they interact. That interaction is the dissolving. Are we together? So I want to see some people in the chat who confirm to me that they have really understood how the dissolving happens and what really makes water a very good solvent. So if they tell you a certain stone dissolves in water, don't even ask for the name of the stone. You just tell them, I don't know the stone, but I'm sure that stone gives us positives and negatives when you add water to it. So those positives and negatives are attracted by water. How? The positives are attracted by the negative on the O of water, and the negatives are attracted by the plus on the H's of water. As simple as that. Okay? So, let me hope I'm with some people. Okay? Now, let's now read the content. Whatever I've been explaining is chemistry. My favorite subject. Now, what is the biology? Let's us first secure our document. And then we go to our beautiful notes. And then we see what the notes really have for us. Where are we? We are here, I think. Okay? Now, whatever we are going to be seeing here, bogus. Serious content has been already discussed. This is now for decoration. Structure of the water molecule. Do you see the oxygen? Do you see the two hydrogens? They are calling that the nucleus. Now, these are the shared electrons, and you can see there are two, and that's what they call a covalent bond. These other ones, they are the ones we say that they are unshared, and we say they are the ones they call the lone pairs of electrons. And then these shared ones, we call them the bonding electrons. Yeah. So you can say lone pairs of electrons or you can say lone electrons. It is very okay. Okay? That is just English. Becky, kindly leave our screen. Kindly leave our screen. I don't know why you are excited. Unless you are ovulating, that I can understand. But if you're not, kindly leave our screen and we study. So they are lone electrons or they are lone pairs of electrons. Okay? Then the unshared, they are those ones. Then the other ones, same thing. You can call them bonding pairs of electrons or just bonding electrons. I think that is okay. Then this side, they were trying to show us the hydrogen bond. So the hydrogen bond can be more correctly named after you showing us the covalent bond. When you show us the covalent bond, then the hydrogen bond can come. You see? Oxygen non-metal, hydrogen non-metal. So that bond is covalent. Sorry. Here in water, this one you're seeing, this one, the bold one. Within the water molecule, we say that bond is what? Covalent. For reasons you know. Then the other dotted one that looks at the interaction between different water molecules in the same area. It is a van der Waals force of attraction. Then because this is so special that it involves hydrogen throughout, we just give it a special name, hydrogen what? Hydrogen bond. Is that really hard? Not really. So let's first read through these things and we see what we meant by all these statements. One thing that usually disturbs students, they want to read a statement and they capture it in their mind that they should reproduce it there and then immediately. That doesn't work. Never do that. So with biology, please and please, just make sure each statement is making sense. Slowly by slowly, as you repeat and repeat, time will reach and the content is very okay. But please try to understand, because the content, the assessment is no longer cram and reproduce. It is cram, reproduce in mind, and then you reproduce on mind, and then you're supposed to apply on paper. Hey, things are a bit serious this time now. Okay? They are saying that water is made up of 2 atoms of hydrogen. You already know that. Sharing electrons with 1 atom of oxygen. Don't you know that already? The result is a stable molecule. I told you the moment sharing happens, stability comes in. Okay? Then they have told you that it is relatively unreactive. Yeah, that's why you can even drink it and don't get any issues. It is just very okay. And it has some unique properties. Okay? They have told you the shape of water is a bit triangular. Okay? But the actual name of the shape in chemistry, they call it a bent shape, or they call it V-shape. Okay? So they can tell you the water molecule is V-shaped. Other people can tell you bent-shaped. Here they are telling you triangular. Hope you can see some triangle trying to come through here. See? They're trying to, as if maybe put an imaginary line there. Okay? And it is not linear. So you realized we had it as linear first, then we explained the chemistry, and we saw the angle. So they are saying that the bond angle we have is 105. Hope that was explained. Okay? Then, here they have been just explaining about polarity. I don't want to read the statements because you people may get confused for no good reason. For the content, you may not even need to reproduce, but rather to make you understand the rest. So let not those things confuse you. But they are saying oxygen draws electrons more towards itself. Didn't we look at that? Creating a negative pole on itself and creating a positive pole on what? On hydrogen, making the bonds polar. So they are telling you oxygen has that net negative charge. Didn't you see it? And hydrogen has the net positive charge. Okay? And because of that, we come up and say that water is a polar molecule. For us, we even added on and we said water is a dipole. And we gave reasons for all that. So those things really shouldn't confuse you. Okay? You go. What are they saying? We proceed with our beautiful notes. Because of this charge separation, you saw the charge separation, negative pole, positive pole. They are saying that water molecules form what they call hydrogen bonds with other water molecules. So you see that with other water molecules nearby, what we are forming are hydrogen bonds. One thing that is so special about these hydrogen bonds that will even help us as we talk about the properties of water and relating them to the function is that they are relatively weak. But this relatively weak should not confuse a student who has been listening to me. If they tell you why they're relatively weak, you boldly tell them they are a form of Van der Waals forces of attraction. And who doesn't know Van der Waals forces of attraction are what? Are weak. So if they're derivative, then chances are high that they are also what? They're also weak. Okay? What else? They are saying that hydrogen bonds are also formed with any other charged particle that dissolves in water. People, didn't you see that? So, what are you learning from this? They have told you that you can even form hydrogen bonds with any other thing that dissolves in water. What does that mean? Let me ask people. Let's read this statement again and I ask you. They are saying in green, they are saying from here, hydrogen bonds are also formed with any other charged particles that dissolve in water. So my question is this. Is this a hydrogen bond? This one. Tell me in the chat. Because water had its Ca structure and the hydrogen had a partial positive charge. You added sodium chloride which dissociated to give you the chloride ion. And this chloride ion being negative interacted with the hydrogen which is positive. My question is that a hydrogen bond according to the statement? Someone has said yes, and that is it. I just need one yes, we proceed. Yeah, because something has been dissolved in water and we are interacting with the hydrogen. So that's also what? Hydrogen bond. This is very nice. Very nice, very nice. Hydrogen bond, HB. So we go. I really like these notes. But I wrote them long time ago when I was very young, just from high school. But they have taught students for years and they have passed. And I'm really a grateful man. Hydrogen bonds are also formed, that one I'm done. Provided something is charged. So you just learn that. Provided something is charged. The moment it interacts with water, water also brings its charges. They interact. I mean, they interact, it has dissolved. Or dissolving has taken place. Okay? Now, they are telling you that hydrogen bonds account for the unique properties of water. So some of the unique properties of water we are going to look at, they will base on hydrogen bonds. That's why I told you that if you don't understand polarity, you will not understand hydrogen bonds, and the whole lesson will be a flop. You'll be gone. Okay? Now, there is one thing that you really need to know. They are what they call isotopes in chemistry. You tell me in the chat, did you study isotopes in O level? Or before you even answer me, have you ever heard of isotopes? And are you aware they are those having different atomic number, but they have the same atomic number, but there is a difference in mass number, which creates a difference in the number of neutrons. Are you aware? Oh, I'm speaking of things that are new. Okay, people are aware of isotopes. So have it in mind, hydrogen exhibits isotopy. That I mean it has isotopes. Even oxygen exhibits isotopy. So we are saying that by weight, 99.76% of water consists of these isotopes. It consists of the isotope, this one, hydrogen 1, then also oxygen 16, okay? The others, or the remaining percentage, which is 0.24, it's for the other isotopes, like the one with atomic mass 2 and maybe atomic mass 18 for oxygen. I think that is very clear, eh? Yeah, the common one is H1 or 16. The others take on the remainder. But these are just facts, eh? You just need to be knowing the meaning of the word isotope. Yeah? And let me tell you, even if you don't know the meaning of isotope, when you look at them and be like, they are comparing H1 and H2. What does that mean? That means the difference is always only with this atomic mass. That's why they are not even bothering to put the atomic number, because it is the same. They're even telling you 16, and the other side they are telling the remainder takes on 18. So the difference is always on these values on top, the atomic masses, and not the atomic numbers. Those ones are always the what? The same for isotopes. Another fact here from a very good textbook. They are saying the commonest isotope is deuterium, which is the H2. That's why they are telling you, okay, they are saying commonest, but again, in the normal water we have, it is again in the other list percentage. In this water of ours, we have H1. This H2 is very bad because it makes that water heavy. Remember, the 2 is atomic mass. So increasing from 1 to 2, you're making things have a greater mass. So you're making them heavy. So the moment deuterium comes and it is part of water, the water becomes heavy. And because of the great molecular mass, that water is very harmful to what? To living things. So if at all you wake up one day and they tell you, why is heavy water harmful to living organisms? I'm sure whoever is listening to this is hearing of heavy water for the very first time. Yet it is going to be in one of the scenarios that are about to come. That one I'm sure. So straight away when you get time, go to your status. Tell people on your status, you type and tell them heavy water is harmful to living organisms because it is composed of the deuterium isotope that really gives water a great molecular mass. And people will be happy. Yeah, don't worry that people will say you have a lot of content. No, it is your status, it is your phone, it's your results, and you will pass. If at all you work with us, passing is a must. It is a must. You will pass, don't worry. So deuterium, because of its higher atomic mass, it makes water to have a very greater molecular mass, making it very heavy and hence harmful to what? To living organisms, okay? How does water really dissolve the polar substances? We are explaining this, and we said water is very excellent at that. So here they are using ionic substances, here they are using salt. But they are saying, okay, you people, we talked of like attracts like. Sorry, like attracts unlike and like repels, things like that. There is something that I really want you to learn. With dissolving, things are a bit different. With these things,
Trucks and
sorry. With dissolving, things are a bit different. And I want you to go with this statement. Just go with this statement and you'll be good to go. You'll be good to go. Just have this statement. And then the interactions are going to be easy for us. If you understand, okay, these ones, just go with these. Polar, polar dissolves polar, non-polar, non-polar, dissolves, non-polar. You people just understand that this is the cheat code to dissolving. If you just understand that, you'll be good to go. You'll be good to go. That is the cheat code to dissolving. That if something is polar, it will only dissolve what is polar. If something is non-polar, it will only dissolve what is what? Non-polar. Someone may be like, why is it like that? You people recall, if something is polar, it's having the positive and negative, isn't it? If something is polar, it's having the positive, I can say partial positive, partial negative. Then if something is again also polar, partial positive, partial negative. So when you mix them, something is really going to happen. You understand that this one is having a positive, it will come and look for this negative. Then also this negative, it will come and look for this what? For this positive. But just assume something is non-polar. It doesn't have charge. So if both don't have charge, they will just interact together. So polar cannot dissolve non-polar. You learn that. If something is non-polar and the other is polar, the other one has charges, this one doesn't have. So dissolving can't happen because we all know dissolving comes from the interaction of the opposite charges. I think that is very clear. No need to overwrite it. Okay. Now that's why you're seeing here, we all know that water is polar. That one everyone knows. So if water is polar, it will only dissolve polar molecules. Okay, They have told you polar molecules like salt. They have given you polar molecules like sugar. That's why and you people also gave me sugar and salt. So it is dissolving them because they are what? They are polar. However, salt we said was sodium what? Chloride. And we said this one was an ionic compound. Why ionic compound? The sodium and Cl connect via an ionic bond. But we shall see that in future. But if I ask you for the structure of sugar, you may not give it to me. And none of you has ever heard that sugar is ionic. That's why they are putting it under non-ionic. So the sugar is non-ionic, but it is polar. And it is polarity that gives it a green flag that water can really dissolve it. Don't overthink. Salt is ionic, but sugar is not ionic. But both are polar. Since both are polar, polar water can dissolve them, period. And we said, how does it happen? They dissociate, they form ions. And the interactions bring about the dissolving to happen. Simple as that. You all saw when ions form, they move freely. They are just freely. Remember when I was placing those ions, I placed them the way I wanted. Because I know when they form, they just move around the way they want. And this makes them chemically more reactive because you realized I was placing them where I can easily form a connection. So this is just English. And because of that, because of water being in position to dissolve those things, you will find that when you take salt, it can easily move in your blood. And then you survive. Just because your curriculum does not really favor transport in plants, but there is where I talk about the xylem and phloem in transport in plants. But don't worry, you will study it in histology and I will teach you. You will see that the xylem helps us transport that water and the salts. The phloem is there to help us transport the sucrose. You understand? And that is called translocation, but that will come. All those are facts. Excretory system. For you to be in position to, for example, urine. Where urine is an excretory product because it is a waste product from metabolism. You study characteristics of living things in senior 1, and they tell you that living things excrete. And they told you that when the body undergoes metabolism, or when metabolism happens, there are those wastes that come off. So those metabolic wastes are the excreta. They're the excretory products, things like that. So things like urine need water for them to be eliminated from the body. Just assume you could pass out urine without having maybe water. It would be really painful and hard. So it's all possible because all those things that come along with the urine can dissolve in water and you can easily pass them out. Something like that. The alimentary canal. You all know it has mucus along the linings of the stomach, linings of the esophagus. The one you call the gullet in some other organisms. So because they are lined with mucus, where mucus is water, mucus 90% is water. You just ask Google right now that which percentage of water is found in mucus. It is more than 90. So you realize that's how water is really so nice. It is everywhere, it just makes things smooth, okay? Then interaction of water with non-polar. Remember, water is what? Is polar. When you tell it to interact with non-polar, it cannot. It cannot. It's like getting water and you mix it with oil. When you get water and mix it with oil, you all know that if at all you get your water, you tell me of water and oil, which one is going to be on top? Is it going to be water on top or oil is going to be on top? You tell me very fast. I want to show you something that is going to help us understand the explanation coming below. Water and oil, when we mix the two, which one is going to be on top? Someone is saying oil, and that is right. So the moment oil gets on top, we shall have we shall have some oil like this. You see that there is a way those oil droplets get together, and also the water is left alone. So there is that form of being called to each other. The water wants to be alone, even the oil wants to be alone. Okay? Now, water being alone and oil being alone, there is how we call that, and we are going to see it. So there is a tendency of each of them just coiling and being around each other and not wanting to interact because of the difference in polarity. Oil is non-polar, water is polar. So they can't join. So they decide each of them to be in their own territory. And that thing of each one's own territory is what we are going to read. Okay? So they are giving you here examples of the non-polar substances, the substances that are non-polar. They're giving you oils. Wherever oils are, we have fats. Okay? They are giving you organic solvents. Organic solvents are so many. When you just put in there on Google, ask for organic solvents, they'll give you so many. They'll give you ether and so many others. Okay? But at least understand oils. That one I've talked about it. And understand wherever oils are, we have fats there present. Okay? And first have those. So they are telling you, remember we said that these water molecules are also being together without intimately. That's what they mean by the water molecules maximizing their hydrogen bonding amongst themselves. Because they don't want to interact with the oil. So they be alone and the oil are alone. So that being alone, it's like they are what? They are maximizing their interaction there. And how do they interact? Via hydrogen what? Hydrogen bonding. Okay? Then we are saying that they are going to repel the non-polar. You understand? Because polar is supposed to dissolve polar and repel non-polar. So this statement shouldn't confuse you. And why is the repulsion happening? We cannot attract because there is lack of charges. And when there is lack of charges, we cannot have electrostatic attraction. I talked about that already. Okay? We cannot have hydrostatic what? Interaction. You need to know that. Now, as I was teaching the eukaryotic cells, we looked at the plasma membrane and we looked at what we call the fluid mosaic model. If you don't have the lesson, that is quite absurd, but at least you find it in textbooks. It's a premium class, so it can't be on YouTube. But there are two words we talked about that I really want you to understand, or that I really want you to learn today. The first one is hydrophilic, the other one is hydrophobic. These are English words, but at least first understand the hydro part. So when they say hydrophilic, because of this word hydro, you all know hydro means water, okay? Then because of this word still hydro, you know that hydro means what? Means water. Now we have this part, okay? We have the philic part, philic. Then we also have the phobic part. You people have heard of phobia. When they say phobia, you really fear something, you really hate it. Let me tell you, phobia for something is either hate or fear. Yes, if you hate something, you have phobia for it, you don't want to interact with it. You understand? So for phobic, they will tell you that things that are hydrophobic, they are called water hating. And philic, you realize if you ask Google the meaning or the origin of the word philic, they will tell you something that relates to love, something that relates to affinity. Okay? So they will tell you hydrophilic things are water loving, hydrophobic things are water hating. That is a functional approach. Okay? So when you look at water, of course, water is water loving because water can dissolve water. Okay? But that's a bit funny. But let me just tell you something like sodium chloride, the table salt. It can dissolve in water, so it really loves water. It is hydrophilic. Look at oil. You add it to water, it clamps itself and it doesn't want to interact with water. Even when you try to stir and mix, later on settling, the oil will go back and be with its oil. It will not interact with water, so it hates water. So it is hydrophobic. So, and remember, oil is non-polar. Oil is what? Is non-polar. So those things of oil trying to avoid water and interact as oil because they hate water, those interactions are what they call hydrophobic what? Interactions. And they will be of great importance when we reach protein structure. And as I also explained them in the eukaryotic cells, hydrophobic interactions very important, but understand them like that. Those non-polar things, not wanting to interact with water, they try to be on their own. and B as them. Those interactions are hydrophobic because they don't involve water anywhere. Okay? And they also help them to cluster them together. So why that car oil, that car oil spill is all together on top of water? It's because of those hydrophobic interactions. Why the water is also remaining down as it water? It's because of the hydrogen bonds that have been maximized within the water molecules. So you will have minimized the surface area for the interaction with water. Things like that. Okay? Now, here they are saying, hope we are moving together and you're noting the content. You're supposed to leave senior 5. By the end of senior 5, we should be done with the syllabus and you just repeat work. You just repeat. Senior 6, you're just revising because you have the content from me. Okay? Chemistry, same thing. Math, same thing. Physics, same thing. And trust me, you shall make it if we just have a year to revise. Okay? Now, these other things I've told you we shall look at them when I teach the fluid mosaic model, which I taught. Maybe if we shall revise it. But what you're seeing here is concerning the surface membrane, which is eukaryotic. So I'm not explaining this here. Then you can see three-dimensional structure of many proteins. So when we reach proteins, we shall discuss. Then this one, when we reach the fluid mosaic model, we shall what? Discuss. So the topic is done. I don't know. I wanted to use 2 hours to reach this point. Are we past 2 hours or we have already reached 2 hours? I told you in the meeting you're supposed to sleep for 5 hours. So whoever is here, I expect you to leave this place at midnight. You sleep and wake up at 4 or 5. Then you go to school at 6 or 7. Depending on the school. But I think between 6 and 7 is okay. And sleeping at midnight, if you're a boy, you sleep up to 6, you prepare 5 minutes, you go to school. As a girl, you may need more time for personal administration. Okay? Now, we are done. The class is done. Because now we are going to talk about biological importances of water. Or they are calling them biologically important functions of water. And these ones are the cheapest. Because trust me, they are just relating. Though you're going to appreciate all of them, but you will need to revisit them for you to understand the concept. And I just want you to maintain the number that you have. If possible, tell people to log on and tell them the lesson has just started. Because you all know the section, you read it. I don't know. I want someone to raise up their hand, anyone who is not dozing and they are sober. To raise up their hand, I ask you to read this for students again. Okay? Because we have analyzed the properties and we really thank God. Now they need the functions, and the functions are the ones we are beginning. So that means we are in the evenings of the class and we are trying to secure our competence as far as the assessment of chemicals of life is concerned. Okay? Now we go. They are easy. So we are dividing them into 3, and you're going to find these ones in biological science. You go in biological science and check. That's how they divided them. All organisms, even in Michael Kent, you find something, even Susan Toole, very good books. So there are those functions that really cut across all organisms, and water plays the same role. There are those functions water plays in plants. Then in plants only, then there are those water plays in animals, and strictly animals only. And they are cheap. If you've been listening, everything is just going to be making total what? Total sense. We proceed. The first one. If a function is not clear, you raise up your hand and ask. Third, as if you want to say something, I don't know. If you really want to say something, lower your hand and raise it again. If there is nothing, I can proceed. Forming part of structure of cells, we saw that, and we saw the percentage. Water being a solvent and medium for diffusion, we saw that. If at all you recall the experiment you did, I don't know. Let me ask, are you the people who did an experiment of O level that included diffusion, that had potassium permanganate, the purple thing that really made the water to become a purple solution? Are you the ones who did that practical? Are you the people? Are you the people who did that practical? Thank you so much. You're the ones. You see, I have a very good memory. That practical caused a lot of issues and made so many students get C's. But I think you saw that if at all we didn't have water, you couldn't notice. You actually couldn't even tell that this thing was to diffuse, to make the whole solution what? Purple. So water is needed for certain things. You know food color. Food color is powder. So when you add orange food color powder to water, the whole thing becomes purple. So water, becomes orange. I don't know if I'm sounding right. If you get orange food color powder and add it to water, the whole water will turn from clear to orange. So water has been key in making sure the orange color diffuses throughout the what? The whole thing. It's a reagent in hydrolysis. Hydrolysis, I want to educate you, and I'm not going to write a lot, but I'm going to just split it, and then people will write. When you see lysis in biology, lysis as in lysis alone, this one means breakdown. Then you all know that hydro means water. So when I combine the word and I say hydrolysis, I'm simply meaning breakdown that really needs the presence of water. Okay? Support for aquatic organisms. You know fish. The moment you put fish out of water, it will die. That means water has been really providing it with support. Fertilization by swimming gametes. You've heard of sperms. For the sperms to really move from the male organism into the female, the females have what we call the cervix. The cervix is in position to produce mucus. So we have what we call cervical mucus. So it is the cervical mucus, and I told you mucus has water. So it is that cervical mucus that increases or that really modulates. It's the one that really gives the sperm that supermotility. It really plays part in giving it that supermotility for it to move to where fertilization is supposed to what? To take place. Disperse of gametes. You all know. You know the coconut seed, it floats on water. So water can really move it from one place to another. That's what they call dispersal. There are some aquatic organisms that have larval stages that are dormant, and these larval stages can also float on water. So the water waves can also move those larval stages from one point to another. That's called migration, and we're also going to see it under animals. Even the dispersal, we're also going to see it in plants. So these are just points, but I'm attaching explanation to them. So you really need to be that student who will add on those small points. Or you should be in position to reproduce the same statements. Okay? The videos are always there. You repeat and repeat. You repeat and put at a speed of times 2. Just that I talk faster for you to get the content. And when you over repeat, you will overpass. Okay? Let's see those functions that really work on plants, or those that are excluded to plants only. Okay? There is a topic that was excluded in your curriculum but so important. It's called cell physiology. It talks about movement in and out of a cell. And there are certain things it talks about. Let me tell you, when a cell takes in water, it enlarges. When it enlarges, it becomes rigid. When it becomes rigid, if it is a plant cell, they say it is targid. So when it is targid and rigid, that means it is very hard that it can provide what? Support. Hope you understand. Most of you have heard of closure and opening of stomata. And you know that when you will lose water vapor through this stoma or this stomata, that's what they call transpiration. So water is also playing part. It is being present in transpiration. We have what we call photosynthesis, and you know that water is needed. I will teach you nutrition in plants, and I will teach you the photosynthesis. And we shall see that in the light stage, there is what we call photolysis of water. And I will teach you that photolysis has the word lysis, which is breakdown, and photo means light. So it is breakdown of water that really needs presence of light for that water to be broken down. And you're hearing water, so water is part. Okay, so it's a reagent in photosynthesis. In primary, we used to say, what are the raw materials for photosynthesis? Carbon dioxide and water. So it's a raw material for it. Okay, hope we are together. So this stoma or the stomata, for them to close and open, there is a mechanism involved, and the mechanism involves osmosis, and osmosis involves water. Who doesn't know that? You even learn it in practical. The osmosis is supposed to be taught so much in practical according to the new curriculum. I told you about translocation that happens in the phloem, which phloem shall be taught in details under histology, subtopic 4 under the branch cell biology. Are we together? But have it in mind, it is transport. But can you really transport something without water? I told you, I gave you an example of urine. Assume we were urinating, but the urine didn't have water content. What would we even be passing out actually? So water is always key for transportation of certain things and so many things that involve transport and movement. Germination. Who doesn't know that germination needs water? When water is taken up, I told you swelling happens or enlarging. And it can lead into breaking open, what they call rupturing whatsoever. Okay? I think these are statements. You see, with biology, I want you to understand so much the points I attach because they will help you in applying the content in question approach. But don't worry, we shall be revising together. If we keep together, but just make sure in whatever you're planning for your A level, you're part of premium. When you're part of premium, that is sure you will pass. Provided you do your role, because me, I play mine. And by the end of senior 5, I've released you. You go. You have a full year senior 6 to determine what you really want. Okay? Because when you go in senior 6 now, I get other senior 5s. I also make sure they have the content well organized before they are senior 6. So I have 1 year me and you to make you super good. Senior 6, I just come in to help you revise. Okay? But as far as content is concerned, I make sure by the end of senior 5, you have it all. Animals, transport of blood. Why really this blood can move inside the blood vessels so well is because water is part. And water just moves so well in the different systems, as you can see. Osmoregulation, this is a full topic. Topic 5, homeostasis. We shall also talk about something on osmoregulation. Osmo, when you see osmo, that is water. So you're regulating water levels in the body. And you cannot regulate them without looking at salts. So osmoregulation combines water balance and salt balance, as we shall see. Just like transpiration in animals, we have sweating. So this is sweating, but dogs do what they call panting. When they pull out their tongue and start breathing heavily, they are looking at how they can lose water vapor off their body surfaces to see how they can really cool. Hope you know that mechanism. If you don't know it, it is also somewhere there in homeostasis. We shall see, don't worry. Lubrications as in joints. You know, joints have what we call synovial fluid that helps with lubrication. Okay? And it is fluid, so there is water. They are what we call annelids. You know, skeletons, we have so many types. And among those types, we have what we call the hydrostatic skeleton. We have the endoskeleton, which we have as man. We have the exoskeleton that is in arthropods like insects. Then we have the hydrostatic, which is so common in worms. Okay? That it is called hydrostatic. When you see hydro, it is water. And you know, skeletons are there to give us support. So it's support, okay? Protection. You have tears. Tears are biologically called lacrimal fluid because they come from the lacrimal gland. It is still somewhere there around the eye. So its tears are called like lacrimal fluid. Okay? We have mucus. You people, don't you know that mucus provides protection? Don't you know that? Don't you know that when you take acid and it enters your stomach, it is that mucus on the stomach wall that can protect you somehow from the effect of that acid? Are you aware? Are you aware the mucus in your nasal cavity can help you trap certain microbes like bacteria? Isn't that really protection? Because the bacteria can cause bacterial infections. Like cryo fluids, are you aware they protect the tears? Are you aware when you cry, you remove dust from your eyes? Are you aware that dust can really cause you eye problems? Isn't that really protection? In the future, I'll tell you that these tears, the lacrimal fluid, have what they call lysozyme. And lysozyme can really break the peptidoglycan. Do you remember the peptidoglycan in the cell wall of bacterial cells? So when it is broken, do you realize the bacteria cannot be protected anymore? And hence we are destroying it. So when we get rid of bacteria, isn't that protection? Oh, that is content. Okay? That's why I told you you need to be having a book and pen ready. On top of these ones, you add on those notes. by the time those other topics come, you'll be having content that really connects and you just enjoy the subject. Migration in ocean currents, I explained this in terms of this puzzle, and I wouldn't want to really explain myself, okay? Now, whatever we have been discussing, that is cheap. That is cheap and it is totally nothing. Now, the real work is this. The real work is this. So we are running with only one page to be done. One page. Biological significance of the properties of water. So we are going to look at the properties of water and how they help. And there are only 13. Unless I've also degraded as far as content is concerned. Hey, there are 12. I don't know where I got the 13th. So this is where we are ending. This is where we are ending. Because now here we shall have begun something else. Water, that's where water ends. Hope we are together. So water stops here. And when we reach there, shall be done. And then the next thing shall be macro what? Macromolecules. So we are only explaining 12 points in 12 minutes and then we leave the place. Isn't that fair? It will even be before midnight. You have some time to think about how hard the subject is as you devise means of really making it in the end, okay? Yeah. So you can breathe in and out a bit. We have 12 minutes to explain 12 biological significances. We end water. I give you the take-home research. And the next lesson shall be premium. And then maybe the next thing we are supposed to have is a physics lesson. So you let the physics students know. Okay? But let me hope chemistry and math is moving on well at school because I gave you the work. If you didn't use the chance, then that is quite absurd. Maybe you had to rewatch twice. Some of you were watching but aren't serious. And you're realizing things are a bit serious. So you gotta be serious also, okay? Have you tried to breathe in and out? Should we go for the properties? Are you ready for the content? Are you ready for the content? But are these people really on? To really check that people are not dozing? You do this for me. You do this for me. You do this for me. I want you to write for me this word in the chat to check if people are really not dozing. I won't say it because there are those on TikTok and they are just listening and not even doing the needful. Write that word in the chat. I see how many people are really following. I may be here, but I'm here alone. Don't write the word more than once. So those are 4 people. I want to see about 20 people at least. That will be fair. I'll know that people are really on and not somewhere else. Okay, those are 5. More 15. If you don't make 15, I'm not going to teach. Those are 6. Those are 7. Don't write more than once. You see only 7 people. That means the rest are not with us, so they are dozing. Candidates doing biology with hope of joining the medical sector. And you're dozing off at 11:30. Just 11:30, even when it is school time, you really need to be serious with yourself. Okay, I can see people now are renaming. They are changing names and they are resending the word. Okay. Some are sending private messages. Okay, those are about 10 people. That is okay. That is okay. That is okay. Now, let's go. Let's go. Those who are on, thank you for staying on up to this late. But I understand people leave school when they are tired and what and what. So whoever reaches this time is really a good person. And I'm really impressed. So they are saying, so what you're seeing here, okay, what you're seeing in bold is the property. Then the other explanation is the significance of that property. Do people get the difference? What you're seeing in bold is the what? Is the property. The other statements are now the significances or the significance of the property. We go. They are saying water is a liquid at room temperature. That is the property of water. What does this really help us? This allows water to provide a liquid environment inside cells and aquatic environment for organisms to live in. Just assume the water was actually a solid at room temperature. That means all our cells would solidify. That means all lakes will be ice. All rivers will be ice and fish won't survive. You see that? So that environment inside cells is very good, and the aquatic environment for those organisms is also very good because it is liquid, so they can really enjoy. Don't say they would adapt. Yeah, this is not betting, this is biology. Solvent properties, these ones were explained. Everyone knows polar dissolves polar, non-polar dissolves polar. And polar doesn't dissolve non-polar, okay? So they are saying the dipolar nature. I told you when you see dipole being related to the nature of water, just know, yeah, that is the game. Okay? So the dipolar nature of water molecules means that any other ions or polar molecules can do what? Can dissolve. You should be a student who can explain this content to people well. You tell them water is polar. You tell them it has a positive and negative somewhere. So when something polar comes in, that means it's also having positive and negative somewhere. So they interact, and like attracts the other unlike. Period. If ions come in, ions are either positive or negative, but water is already having its positive and negative. So the interactions can happen from interactions or attractions of the unlike. Period. So that really makes water a good solvent. And because of that, glucose can move in our blood. Most of you have ever taken glucose. It immediately gets absorbed into the bloodstream. So it can move because it is polar. The blood has water, so the water in blood welcomes that glucose because both are polar. So the glucose moves in peace. For you to translocate the sucrose in the phloem, water is inside the phloem. And because the sucrose coming is also polar, sucrose is sugar. Just because I feel bad that carbohydrates are not supposed to be taught in the curriculum, but it is really very bad. And these are things you're supposed to look at, you as a person. There are schools that are teaching carbohydrates because you need them, but they are not on the syllabus. But you need them because they are really nice and you may meet them. But first we shall find a way of understanding them in relation to what we need to know. And then we shall pass. Removal of wastes. You all know these things of ammonia and urea. These are things that are part of urine. So you got the urine part. So ammonia can dissolve in water. Urea can dissolve. Since they can dissolve, we can easily remove them. Because what we are passing out is liquid form. So if they can dissolve in that liquid, they can also be what? Eliminated. The enzymes need water. So water can provide that medium for us. The tears we are secreting, they are in liquid form. If water wasn't part of them, maybe it would even be hard for us to secrete them. I don't know whether people are connecting stuff. Okay? High incompressibility. Let me tell you, water is very hard to compress. Yeah, I know people know that. So this is going to go back to the hydroskeleton I talked about. You people, you've seen those earthworms. Those earthworms, unless you apply a lot of pressure, but they are hard. If you try compressing them, there is a way it just slides and it goes. But don't say if I get a brick, but it can break. No, the incompressibility we are talking about is environmental pressure, not that pressure of yours of applying things by force. But the environmental pressure cannot really compress that hydrostatic skeleton of worms, and it bursts them. So that high incompressibility of the water that is making up that skeleton makes it really so hard for that pressure to be felt, for the skeleton to be broken, for the worm to burst. Are we together? I also told you about the turgidity. Turgidity is that rigidity. So this incompressibility really relates to the support. Take in water, swell, enlarge. Become rigid, that is turgidity. Provide support. Okay? I think we are together there. Water is denser than air. Who doesn't know that? Because in most of the cases, air is above water, so air is less dense than water. Or water is denser. Okay? And that's why water can really support organisms like whales. Those large ones. You understand? Okay? I think that is not so hard. That is not so hard. The mere fact that water is dense enough, it can support those large organisms like what? Like whales. But air can't. Because the moment the whale goes into air, it will just fall off. Okay? If at all you're holding a pen and you're holding it on top of a basin full of water, if at all it falls and then it comes on top and it floats, that means why it fell from the air, why it didn't stay in air, it's because it was denser. But then it is falling in a basin and again coming on top of the water in the basin. That means it is less dense than water. And since it is less dense than water, but it was more dense than air, that means even air is less dense than water. Water is denser. Hey, just get the English. But if you've gotten it, that's a property of water. Its relationship is that, you know, the coconut seed, it can float on water, but you put it in air, it falls. Okay? Ice floats on water. Who doesn't know that? Someone may be like, now, isn't this a property of of ice? But remember, ice is solid water. Those who do chemistry, you learn a topic called phase equilibrium. I will teach it to you myself. But I taught it already and it never changed. So you just watch the same videos. So ice is solid water. This normal water is what they call liquid water, the one that is liquid. Ice is water but solid. Then the other steam is what they call gaseous water. So water is one of those things on earth that can exhibit in all the three states of matter. Water can be a solid as ice, water can be a vapor as steam, water can be a liquid as just normal liquid water at room temperature. But you all know ice floats on water, don't you know that? Simply get ice, get water, mix them. You see the ice floating. Ice can never sink. You try it, it will never. So because of that, you have seen if at all a lake is to freeze, it will freeze from top. And then the ice will occupy the top. But down it will be water. I don't know whether people have realized that. I don't know for you, but I've been to Germany for certain studies. And when it is winter, when ice is on top, down there is water. For those small water ponds that exist. So when that ice is on top, it allows organisms that are down not to experience these cold conditions out. I don't know if people are getting. Remember, outside it is cold, it is winter. And on ice goes on top of any water body. So the organisms down are going to be feeling kind of warm. So the ice is acting as an insulator. It is trying to insulate. It is trying to prevent heat loss from the organisms that are below it. I don't know whether people get the science. The ice is cold, but it is insulating those below it. Someone may be like, but the water is already cold. It is cold, but it is not ice. That means it is warmer than ice. So the ice on top is trying to do what? To do some bit of insulation, preventing them from what? From heat loss. So in that way, there is really survival. Hope you're connecting stuff. Okay? These things of high surface tension and cohesion, we are now on 6, remember they are 12. So we are already halfway. Remaining with 1/2 and then we are good to go. High surface tension and cohesion. You really need to know these two things. That cohesion is the force that really holds same molecules together. Then we have what they call adhesion. And adhesion is the opposite of cohesion. What does it do? For it holds the different ones together. That one I've not written it, but I've said it. So I expect you to take note. Cohesion, it holds those that are similar together. Adhesion holds those that are different together. It's all about holding things together. Okay? Now, when the water molecules hold themselves together as water molecules, they develop some surface tension or on top of them. That's why we have organisms, they're called water skaters. I don't know whether they were here. It's here. These water skaters, they skate on water. Even if it's not water skaters, you've seen small birds. You can hardly hear small birds. You've seen those small birds that really stand on water and there is no problem when they stand on water, like no problem. I know someone here, at least you've seen those small birds. So why those small birds can stand on water? It's because these water molecules hold themselves together so much, they are similar. So there is that cohesion. That cohesion makes the water develop a surface what? Surface tension. And that surface tension is going to give that water the ability to hold these water skaters and the small birds. I think that is very clear. Okay, that is not hard. Then also, as water is moving in in the xylem, I told you this, you see it in histology, but transport in plants is not part of your syllabus. But just understand that plants have what we call the xylem. And this xylem is important for transportation of water. So for this water to move continuously as a column, for it to move as one column, it should really be in touch. The water molecules should be in touch with each other. They should hold each other and move as one column through the xylem. So that thing of holding each other is the what? Cohesion stuff. I think that is not very hard. Okay? The rest is just English, you making your statements, but understand the biology. They are talking of this water having a high tensile strength. It is what I've just explained. If at all the water is highly cohesive, that means these water molecules that are similar are holding themselves so strongly in that when you try to separate them, it is hard. Just assume you're holding a shirt and like you want to tear it. It is hard because those molecules of the shirt are the same, so they are holding each other so strongly. So you trying to tear them is hard. You need a lot of energy. And you all know that that force that really pulls things apart is what they call tension. So you need a lot of tension for you to tear a shirt or a trouser or anything. So the moment cohesion is in place, those similar molecules are holding themselves so tightly, so you trying to tear them up, it is very hard. Because they need a very high tension, that's what we call water having a very high what? Tensile strength. Anything that needs a lot of force, a lot of tension to tear, to pull apart, has a high tensile what? Strength. And it is that thing I explained that it will enable water to move upward in a xylem as a single column. I think these water columns move upwards without breaking or pulling apart. Because pulling them apart needs a lot of force. They have a high tensile strength. Why? They already held themselves together so tightly. So pulling them is very hard. So it will move straight as a what? A column. Water, on top of being highly cohesive, it's also having a very high adhesion. Someone may be like, now this is contradictive. It's not. It's not. Remember, we are looking at how water is supposed to move upwards. Let me tell you, if this is the xylem, the tube through water is moving, and this is the water moving, you people, do you agree with me that for this water to move, it is supposed to touch this? This is the wall, okay? This is the wall, and then this is the water molecule. So, do you people agree with me that the water is supposed to touch the wall for it to keep moving upwards? Because it's not going to just move in space, no. You people, you've looked at water coming from a tap through a pipe to somewhere. For that water to move, the water interacts with the wall of the pipe and it moves. So adhesion is needed. Where is the adhesion? The adhesion is the attraction between the water molecules and the molecules of this pipe wall. So water should have that high adhesion such that it can touch the pipe. If it touches the pipe, now it starts to move. Or in any tube, it is in. I don't know whether you're getting the adhesion part. Don't feel tired. We're on point 8 and they are 12. So we are done. Don't worry. Okay? Don't worry. So that is the adhesion. So for water to move, there is what is needed, and that is what? Adhesion. For it to touch molecules of the pipe, because there are different adhesion comes in. So it will keep water what? Moving. Water is a reagent. I think we saw this. Water is a reagent. We saw that. That is not really hard. It is in so many cases of metabolism, like in photosynthesis. And what does it do in photosynthesis? It is a source of hydrogen. And we shall see that when we reach the dark stages and so on of photosynthesis. We shall see the role of hydrogen. What is another property of water? Water is colorless and transparent. Because this water is transparent, what is it going to help us? It is going to allow light to penetrate, and it will allow aquatic plants to photosynthesize. There are plants in lakes, there are plants in water bodies, they are aquatic. They need to photosynthesize to make food to survive. So if water is transparent, light will really penetrate and photosynthesis will happen. Photosynthesis. Photo means light is required, okay? Because of the colorless, assume water was black. Then we organisms could not see. But because the water is colorless, vision is actually made possible. Animals or predators can see their prey or food in water. Okay? So transparency for penetration of light. Colorless, predators to see prey. Predators and prey, that is in ecology. If a lion feeds on an antelope, the lion is predating on the antelope. So the antelope is the prey and the lion is the predator. Water has a low viscosity. Viscosity is a measure of thickness. So when you see the word viscosity from today and onwards, when you see the word viscosity, look at it or take it as a measure of thickness. Hope we are together. So when they say something has a low viscosity, that means it's not so thick. If something is highly viscous, if it's having a very high viscosity, that means it is very thick. Something that is very thick does not move freely, it moves slowly. But something that is less viscous, something that has a low viscosity, it can really move freely and very fast. Okay? That's why we are saying that this will allow water to move freely through narrow. You see, they're adding the freely and quickly and they're adding it to narrow. Something that is not so thick is what can move through something that is narrow. But assume something is assume you want maybe oil to enter a lid of a pen. It will really be hard because ink is less viscous. Ink is less thick than oil. That's why for it can fit in the ink lid. But oil can't. Even when it can, it's a bit hard. You understand? Then we talked about the lubricant, those things we talked about. I told you the esophagus has mucus, and that's why the food can really move through your throat and you don't feel any problem. Because the mucus there is allowing the food to move freely. And the mucus has water. And it's that water solution helping us with the lubrication. Is that really hard? Then lastly, I want to teach you this and go with it. And we shall also need it in chemistry. Okay? If at all we are having X, and the X gets surrounded by water molecules. Are you seeing this? X has not dissolved, but X has gotten surrounded by water what? By water molecules. The moment it gets surrounded by water molecules, we say that X is hydrated. X is what? Yeah, you take that home. You take that home. So important. Yeah. The moment X gets surrounded with water molecules, we say that X is what? Is hydrated. So let's read this last point and see if we shall understand. They're saying that water combines with many organic molecules to form hydrated molecules. Okay? Now, anything that is hydrated, you can heat it and the water later gets lost. I don't know whether you people are getting me. If at all the X gets surrounded by water molecules, I just say it is, we have said surrounded, please, not dissolved. Getting hydrated and forming a solution, they are two different things. That's why in chemistry we have enthalpy of hydration and enthalpy of solution. Because enthalpy of hydration looks at what? Getting surrounded by water only. Then for enthalpy of solution looks at dissolving and forming the solution. So when something is hydrated, later on you can heat. So the moment you heat, you form X. You form X that has no water. And X that has no water is called the anhydrous. I know that people are aware that the opposite of hydrated is anhydrous. So it's like you're back to your X. The X is back. You had X alone, you surrounded it with water, it became hydrated. You did some heating, then the X came back. You understand? So like the X is back with its properties. So the mere fact that this is water, it has that property of surrounding things, it makes them hydrated, but their properties are maintained because when you heat, they go back to the anhydrous states, the states in which they were. And then the properties are just what? are just maintained. So this is the statement that water combines with many organic molecules, and the molecules we form, the new ones are what? Hydrated. And this will allow the properties to be maintained, both physical and chemical properties maintained. No problem at all. And you people, that is all. That is the end of the class. Thank you for attending. Now stay on for a minute to listen to the assignment, and then you go, you sleep. We have 8 minutes to midnight. I know I'm going to release you before midnight. And next time we shall begin early enough. Okay? Thank you for being perseverant. Thank you for enduring. That's what happens in the medical sector. So the assignment is very clear. The assignment is very clear. Yeah, the assignment is very clear. Not hard. So you're supposed to read. Supposed to read today's content. You're supposed to read today's content. Yes. Summarize or take notes. Whichever you want. There are those who don't have notes, you take notes. There are those who have the notes already, you take summaries. Okay? That is one. That is the assignment. Okay? Then you're supposed to read again. Yeah? Then that is the assignment. Then research. Now, before I give you the research, I want you to first take screenshots. I don't want people to ask me for these things after, because I will not give them to you. I told you these are the notes we just give some of them, not all, to the premium students, and we don't sell them, okay? So you're going to take screenshots. I think we stopped on the very first one. I think that was it. So very first, we are taking screenshots, okay? You take that. Okay, let's make it more clear. You take that screenshot, okay? Then after you take that screenshot, so important. There are those other screenshots I'm leaving out the writings, eh? Just be wise enough. As I scroll like this, you take another one so that you have those things of water loving, water hating. Just be sharp, because I know someone has them already. You take those ones. You take that one also. I give you the research, the take-home research. It's about lipids, yeah? And we shall have a class of lipids. We have that of protein. Those of proteins will be so many. We shall cover this work slowly, and in the end, those will be part of premium. We shall complete. Yeah, it's not so scary. Okay, then you take that also. Take that also. Take that. I think Shalom has been the most focused student for this lesson. Avid has been on and she has not dozed even at any one point. Okay, macromolecules, that is the end. So we are done with water, and I told you, I only end classes, I only end the lesson if I told what I wanted to cover is done. So this is it. The research, I want you to go and find out what macromolecules are. As you find out what macromolecules are, please, you define them, okay? Then after defining them, I will need some examples. Yes, define them, and then you give me some examples. Then the very first macromolecule you are supposed to cover, they are lipids. These ones I told you, according to the curriculum. Even when you check the book, it's here. After water, which we are done with completely, they are telling you to handle simple and conjugated lipids, their properties and functions. Then the next thing shall be proteins. Then in the end, they are the nucleic acids, and you all know nucleic acids we got done. Remember this year we are, okay, I'm just supposed to cover senior 5 work at my own pace until I complete it this year. So I can even decide to have another class when I want, because the senior 6 topics are already there waiting for you. I don't know if people are aware of that. Some of you are not aware that the classes, the classes are already there waiting for you all. Maybe I should try to show some of the work, because people may be taking things for granted. Let me show you something small. Let me show you some of the senior 6 work of biology that it is done. So here, principal biology folder, senior 6, you see, term 1 work, it's there, coordination in animals, the classes are there. We have term 2 work, inheritance and evolution, nucleic acids, they already taught 4 classes, cell division, I think we had 3 modules there. Then term 3, that's where we have this ecology. Someone may be like, 1 topic per term. Yes, term 3 has 1 topic ecology, term 1 has 1 topic coordination. Yes. Then term 2 is having 2 topics. Those are 4. Then in senior 5, there are 5 topics. We're already handling 1. That means we have 4 to go. You see? So we are moving. So you really need to be sober. And you really need to be sharp as we are covering all this, okay? So back. So lipids are the ones we are supposed to cover next. So the take home is very important. Lipids, I want you to define and you give me the types. Okay. Then after that, I want you to tell me the constituents of lipids. So these are the things we are supposed to cover in the next class. But you forgive me, this class will not be posted on YouTube. If it's posted, then it will be for, I mean the one of lipids. It will be for members only, but it will be premium. I told you that, so that we give respect to those people who really enroll or premium. So you look for the formation of the triglyceride, TG. Then I will want you to look for the properties. Lipids and relate them to function. It's exactly midnight and the lesson is already done. We are just giving assignment, and relate them to function. There are those functions that you may fail to relate to properties. I call them miscellaneous functions. So we can also have that part of miscellaneous functions. We shall have them there. Okay. Then there is something that people may really miss out. I want you to say something about these things. You're supposed to tell me something about sterols. You're supposed to tell me something about waxes. They're so important. Application. They will be so high yield. Tell me about phospholipids. Okay. You're supposed to tell me something about glycolipids. Okay. Then you're supposed to tell me something about lipoproteins. Lipoproteins. Yeah. So that is the take-home research. Yeah. So you can take a screenshot for that research so that you don't forget. So make sure by the time you come, you know that. So our research, this research is the next stop. By next stop, I mean what we are going to cover next. That is our next stop. So the screenshot is done. Thank you once again for attending. If you have any other concern, I'm really not happy because there are people who left intentionally and never thanked me for the free class. That is very bad. And even you are on, I've not seen anyone telling me thank you because the lesson got done long time ago. It's only one person. It's only one person. I don't know, maybe the rest have not understood. Maybe I've wasted their time. Okay? But thank you for coming through. We shall meet. Let's keep communicating in the WhatsApp group and the channel. So I sign out as a Paul Tutor, a member of Science Scholars Academy Uganda. And I'm a tutor of science and math. Okay. The personal contact 753 79592 to become part of premium. Okay. Yeah, I think in the chat it's only appreciation messages. Thank you so much. Thank you for listening. I'm also going to share this workbook in case I forget. You let me know. And it will also be in the description of the YouTube video once posted. Otherwise, bye-bye. We meet again in lesson 2.